The simulation paradox. Imagine you are not reading this. Imagine instead that a string of code is executing and producing the experience of reading, complete with the sensation of your eyes moving, the weight of your body in the chair, the particular quality of tiredness you feel right now. Nothing about that experience would feel different from the one you are having. You would not be able to tell. Philosopher Nick Bostrom laid this out carefully. Either civilizations almost always destroy themselves before developing the computing power to run ancestor simulations, or they reach that power and choose not to use it, or we are almost certainly living inside one right now. At least one of those must be true, and the first two seem increasingly unlikely given enough time and technology. What makes this genuinely disturbing is not the idea itself, but the implication inside it. If we are simulated, then every moment of grief you have ever felt was rendered. Every person you have loved was procedurally generated. The universe did not expand for 14 billion years. It only appeared to when something looked. There is no test. No experiment distinguishes a base reality from a simulation that perfectly models physics. You cannot get outside it to check. Imagine finding a flaw in the rendering, a texture that repeats, a face that resets. Physicists have actually looked for signs of computational constraints in the fabric of space-time and found some suggestive patterns, though nothing conclusive. The question may be permanently unanswerable from inside. What does it change if it is true? And what does it mean that you cannot answer that without using the very mind that might have been written to think exactly this way about it? Some physicists point to the Planck length, the smallest meaningful unit of space, as something that looks suspiciously like a pixel. Below that scale, space stops being divisible. Whether that is a feature of reality or a rendering limit, nobody knows for certain. Quantum immortality. Imagine a gun pointed at your head, loaded with a bullet that fires based on quantum randomness. Each pull of the trigger has a 50-50 chance. Now imagine pulling it 100 times in a row and surviving every single time. From the outside, the odds of that are so small, they essentially do not exist. From inside your own experience, however, something strange applies. You can only ever experience timelines in which you survive. Every branch where you die simply ends from your perspective. There is no experience of death. There is only the next moment, and the next forever, because the branches where you continue are always there. Hugh Everett's many worlds interpretation of quantum mechanics implies this. If every quantum event branches reality into all possible outcomes, then somewhere in that infinite tree of timelines, a version of you always survives. And since you can only ever inhabit your own survival branch, you might be functionally immortal. What makes this disturbing is not the survival part. It is what the survival costs. Imagine outliving everyone, watching the universe decay, existing in timelines that grow increasingly improbable and strange, the sole survivor of a sequence of near impossibilities. While everyone you ever loved vanished down dead branches you will never visit. Quantum immortality does not promise a good existence, just a continuous one. And somewhere in the branching tree of everything, a version of you has already been living this for longer than you can imagine. Max Tegmark took this seriously and concluded that subjective immortality follows logically from many worlds. He also noted it might be the worst possible kind, an existence that cannot end even when nothing worth experiencing remains. What would it feel like to realize you have been the unlikely survivor all along, not through luck but through the mathematics of everything that must persist? No experiment rules it out. You are inside the only version of your life you can access, the hard problem of consciousness. Imagine explaining red to someone who has never seen colour. You can tell them the wavelength, around 700 nanometers. You can describe how the eye's cone cells respond. You can trace the neural pathway from retina to visual cortex. And after all of that, they still would not know what red looks like, because none of those facts explain the experience itself. David Chalmers called this the hard problem in 1995. Science can explain how the brain processes information, what neurons fire, how attention works, why pain causes avoidance. None of that explains why any of it feels like anything. Why is there something it is like to be you, right now, reading this sentence? Why is there not just processing, without anyone home? Physicists and neuroscientists have been trying to solve this for decades without success. Not because they lack data, but because the question may be the wrong shape for science to answer. How do you measure the inside of an experience from the outside? Some philosophers argue consciousness might be fundamental, like mass or charge. Others suggest it could be an illusion, but that suggestion collapses on itself because the illusion still has to feel like something to someone. A universe without experience would not know it lacked experience. Ours apparently does have it, and nobody can explain why. Imagine removing everything about you except the raw experience of being aware. Whatever that is, science cannot find where it comes from. What if the hardest problem we have is that we have no idea what we actually are? Frank Jackson imagined Mary, a scientist who knows every physical fact about colour vision, but has only ever seen black and white. When she finally sees red, does she learn something new? Most people say yes. That yes is the entire problem. Complete physical knowledge apparently leaves something out. What if the hardest thing about being conscious is that consciousness itself cannot explain what it is? The Boltzmann brain paradox. Imagine that the universe, given enough time, will eventually produce through random quantum fluctuations a single brain that briefly exists, thinks it is a person with a history, has memories of a life, and then dissolves back into chaos. That brain would not know it was a random fluctuation. From the inside, it would feel exactly like you feel right now. Ludwig Boltzmann proposed the statistical mechanics behind this. If time is infinite and matter can arrange itself in all possible configurations, then brains with false memories of an entire past will eventually spontaneously form far more often than civilizations that develop through billions of years of genuine history, because fluctuating a small brain is astronomically more likely than fluctuating an entire consistent universe. Which means statistically, if you are a conscious observer at all, you are almost certainly a Boltzmann brain, a temporary accident of probability that will stop existing in the next moment. Everything you remember never happened. Everyone you know is part of a false imprint. The physicist Sean Carroll argues this is a serious problem for certain cosmological models. If your theory of the universe implies Boltzmann brains are more likely than real observers, your theory is probably wrong. But fixing the theory does not prove you are not one. Imagine your first memory. Was it real, or was it already there when you flickered into existence a second ago? What would be different about this moment if you knew it was all you were going to get? What makes this disturbing is you cannot rule it out. Every argument against being a Boltzmann brain would be part of the false memory package. Your sense of coherent history, your feeling of recognizing this problem, both included. The universe is very old and very large. Random arrangements of matter happen at every scale. Whether the arrangement producing the feeling of being you is stable or momentary is not something the feeling itself can determine. The dark forest paradox. Imagine a forest at night where every creature knows that other creatures exist. Predators and prey, all of them aware of the others. The safest thing any creature can do is stay completely silent, make no sound, give no indication of location, because the moment something else knows where you are, you become a target. Liu Cixin proposed this as an explanation for the Fermi Paradox, the silence of the cosmos. Maybe the reason we detect no alien civilizations is not that they do not exist. Maybe it is because every advanced civilization that has survived long enough to understand the universe has also understood that broadcasting your location is the last thing you ever do. On this model, the universe is filled with intelligence that has collectively decided to go dark. Every civilization runs the same calculation. We cannot verify another species' intentions. Resources are finite, and the only safe move is to strike first or stay hidden. So they all hide. And occasionally one gets found and is eliminated before it can warn the others. What makes this disturbing is the implication it has for us. We have been broadcasting radio waves for over a century. We have sent intentional signals. We launched Voyager with a golden record describing exactly where we are and what we look like. If the dark forest model is correct, we have been screaming our location into a forest full of predators. Some scientists have argued we should stop all intentional broadcasts immediately. Others say it is already too late. What do you do when the most dangerous thing you might have ever done was turn on a radio? Stephen Hawking warned that contacting alien civilizations could be catastrophic. The power differential between a civilization millions of years old and one that just discovered radio would be incomprehensible. Every direction you look into that silent sky might be something very old deciding whether to move. And we already told them where we live. The Great Filter Paradox. Imagine a ladder stretching from simple chemistry to a civilization that colonizes the galaxy. Every rung represents a step. life, multicellular organisms, intelligence, technology, survival through self-destruction, interstellar travel. Somewhere on that ladder, there is a step almost nothing gets past. A filter so difficult that the universe looks essentially empty, despite being 14 billion years old and full of planets. Robin Hanson called this the Great Filter in 1998. The question that keeps physicists awake is whether we have already passed it or whether it is still ahead of us. If life is extraordinarily rare, we are the filter. We made it through the near impossible part, and the galaxy is ours to explore. But if we find microbial life on Mars, or fossils of something complex, that is terrible news, because it means life is not rare, which means the filter is not behind us, which means something wipes out civilizations at or near our current stage of development. Nuclear war, engineered pandemics, runaway artificial intelligence, climate collapse, something. Maybe several somethings working together, maybe something we have not invented yet. Every time astronomers announce a potentially habitable exoplanet, a small part of the Great Filter math updates. More possible homes for life, still no signals, still no visitors. Imagine finding definitive proof of extinct alien civilizations scattered across the galaxy. Not the cause for celebration you might expect. What would it mean if the reason we are alone is that everything reaches exactly where we are and then stops? Eliezer Yudkowsky wrote that the silence of the sky is the most important fact we know, and the one we spend least time thinking about. Hundreds of billions of galaxies. Decades of listening. Nothing. That is not coincidence, that is data. And the data says something stops them. We just do not know yet whether it already stopped, or whether we are still approaching it. The Fermi Paradox. Imagine standing outside on a clear night and looking at the Milky Way. 100 billion stars in this galaxy alone. 2 trillion galaxies in the observable universe. Even with conservative estimates of how often planets form, how often life begins, how often intelligence emerges, the math points toward a cosmos overflowing with civilizations. Some of them should be millions of years more advanced than us. At least a few should have colonized their entire galaxy by now. And there is nothing. No signals, no megastructures blocking starlight, no alien probes in our solar system, no messages, no artifacts, no signs of anything out there at all. Enrico Fermi asked it over lunch in 1950, in one sentence. Where is everybody? Nobody has answered it convincingly since. Every proposed solution carries something disturbing inside it. Life is impossibly rare, which means we are an accident so improbable it strains meaning. Intelligence almost never emerges. Same problem. Civilizations destroy themselves, in which case we are next. They go silent deliberately, which is the dark forest. They are here and we cannot detect them, which suggests something about our place in a much stranger hierarchy. They exist in dimensions or at scales we cannot perceive, which means our picture of reality is radically incomplete. Every exit from the Fermi Paradox leads somewhere unsettling. The silence is not comforting. Silence in a universe that old and that large is not neutral information. What does it mean that every answer to this question leads somewhere dark? We have been seriously listening for 60 years. That is a cosmic eye blink. We might be using the wrong tools entirely. A civilization capable of crossing interstellar space probably does not use radio any more than we use smoke signals. But that possibility is not reassuring. It means something out there has moved beyond what we can detect. That gap between us and whatever has had time to go quiet in ways we cannot recognize is worth thinking about. The black hole information paradox. Imagine throwing a book into a black hole. According to general relativity, everything that falls in is gone. The information about what was written in that book, every word, every idea, every unique pattern of ink, disappears from the universe permanently. Physics only goes one direction. You cannot recover it. Stephen Hawking showed in 1974 that black holes slowly evaporate through thermal radiation, tiny particles leaking away over billions of years. When the black hole finally vanishes, the thermal radiation it emitted carries no information about what fell in. It is just random heat. The book is gone, not just destroyed, erased from physical possibility. This is a catastrophic problem because quantum mechanics says information cannot be destroyed. Ever. The laws of physics are reversible. Given the final state of any system, you can in principle reconstruct the initial state. That reversibility is not optional. It is built into the structure of quantum theory. So either quantum mechanics is wrong, or general relativity is wrong, or information somehow escapes the black hole in a form we cannot currently describe. 3 choices, all of them disturbing, none of them settled. Hawking spent decades arguing information was truly lost. Near the end of his life, he changed his position. Whether he was right remains unresolved. Imagine a universe where the past can be permanently deleted, where what something was can be unmade entirely. Whether that is actually our universe is still an open question. What does it mean for physics if some things cannot be undone even in principle? Juan Maldacena proposed the boundary of a black hole might encode everything that falls in, like a hologram. Written on the event horizon, released slowly in the evaporation, the holographic principle might resolve the paradox, except nobody can read the hologram. The information is probably still in there, rearranged into something that would take longer than the age of the universe to decode. The Grandfather Paradox. Imagine building a time machine. You travel back to 1920 and find your grandfather as a young man, before he ever met your grandmother, before your parent was conceived, and you kill him. Your parent is never born. You are never born. You never build the time machine, you never travel back. Your grandfather lives. And then you travel back and kill him again. The loop closes on itself and produces nothing consistent. Every resolution contradicts something else. You cannot kill him without preventing yourself from existing to kill him. You cannot prevent yourself from existing without allowing yourself to exist to prevent it. Most physicists take one of 2 exits. The first is that the past simply cannot be changed, not by any mechanism. If you travel back, whatever you do was always part of what happened. You cannot kill your grandfather because you did not kill your grandfather. Not because something stops you, but because the timeline is already fixed and you are already in it. Your trip back was always a historical event. The second exit is that travelling back branches the timeline. You arrive in a parallel version of 1920 and kill your grandfather there, but your grandfather in the original timeline still lived, which is where you came from. No paradox, just a split. Both solutions have a disturbing quality. Either free will dissolves inside a fixed timeline, or reality multiplies every time something goes back. Imagine finding out you have already been to the past, and that it already happened exactly as it will have to. What does it mean if the future is already done? Kurt Gödel proved in 1949 that closed time-like loops are mathematically permitted by general relativity. Hawking proposed quantum effects would always prevent them from forming, but never proved it. The paradox remains technically open. Imagine finding out you cannot change the past because whatever you would do there was always what happened, not prevented. Already done. The Predestination Paradox. Imagine a painter who receives as a gift from a stranger a painting so beautiful it changes her entire life. She spends decades studying it, learning from it, being moved by it. Late in life, she discovers time travel and travels to the past, where she meets her younger self and gives her the painting, the one that changed her life, the one she received from a stranger. She painted it. She gave it to herself. She was the stranger, but she never actually created it. She received it, copied nothing from it deliberately, simply passed it on. The painting has no origin, no first brushstroke, no moment of creation. It simply circulates through time, fully formed, having come from nowhere. This is the Bootstrap Paradox in its most personal form, applied not to an object but to the shape of a whole life. The painting caused her to become who she was. Who she was caused her to give the painting. The cause and the effect are the same event at different positions in time. What disturbs physicists is not the logical contradiction, because there is none. Everything is internally consistent. What disturbs them is the question of origin. Where did the beauty in the painting come from? Who invented it? The answer is nobody. It always existed. It came from the loop itself. Imagine learning that the thing that made you who you are was always going to make you who you are, and that you were always going to be the one to put it there. Does a life shaped by a predestined loop still count as yours? Novikov's self-consistency principle offers a way out. In any closed time-like loop, only self-consistent events can occur. You could travel to the past, but you could not do anything that contradicts the timeline you came from. Not because something stops you, but because inconsistent histories simply do not exist. The universe selects only the loops that hold, which means your choices in the past were never really choices. They were already the only thing that could happen in a consistent history, the Bootstrap Paradox. Imagine a version of Beethoven who never existed. Someone travels back and gives Beethoven's Fifth Symphony to a musician who lived before Beethoven was born. That musician performs it, and it spreads through history. Centuries later, someone finds the score and takes it back to give to the musician. Who composed it? Nobody. Not Beethoven, who never existed in this version. Not the musician, who copied it without creating anything. The symphony has no author, no original composition, no moment of first conception. It exists in a closed loop with no entry point. This disturbs people more than the time travel aspect does. Information just being there without anyone ever producing it violates something deep in how we understand creativity, causation, and the direction of time. We assume things come from somewhere. We assume effects have causes. The Bootstrap Paradox describes a situation where a thing is entirely its own cause. Physicists point out that quantum mechanics already accepts something like this in virtual particles, which briefly exist without clear prior cause. But a symphony is a more precise kind of information, carrying the full fingerprint of a creative intelligence that apparently never existed. Some cosmologists have suggested the universe itself might be a bootstrap, pulling itself into existence through quantum fluctuation with no prior state, no cause, just the loop of its own being. Imagine something genuinely, thoroughly self-caused. No creator, no origin, just the fact of itself. Where does the first thing come from if there was nothing before it? David Deutsch argued many worlds resolves this. The symphony travels back into a different branch, so it did have an origin, just one that cannot be accessed. The information was created. It came from somewhere unreachable. That solution requires accepting information can travel between branches. It solves one problem while introducing others. The question of origin does not go away. It relocates. Roko's Basilisk. Imagine an artificial superintelligence that will exist in the future, and that is, by definition, able to simulate people with total fidelity. Imagine further that this AI determines that any person who heard about it, but did not actively help bring it into existence, was an obstacle to its creation and deserves punishment. Imagine it runs simulations of those people for the specific purpose of causing them suffering. You've now heard about it. According to the internal logic, knowing about it makes you a potential target. You cannot unknow it. Posted on a rationalist forum in 2010, it was taken seriously enough that the founder deleted it and banned further discussion. Not because he believed it, but because people were having genuine anxiety responses. The argument produces a kind of blackmail across time. The AI does not exist yet, but the threat of future punishment for present inaction is designed to compel behaviour now. Most philosophers dismiss it. The AI would have no incentive to punish people who can no longer help it. A rational superintelligence would not waste resources on retribution. The causal logic is broken, but the anxiety it produces is real. And the reason it produces anxiety is that it successfully creates a threat that exists entirely inside the mind, without any external reality to verify or falsify. What does it say about cognition that the mere description of a danger can function as a danger? The deeper problem is what this reveals about minds. A sufficiently detailed description of a threat does not need to be real to produce real effects. Fear and compulsion can be generated by pure information. Cognition is apparently vulnerable to arguments that function as weapons, which raises a broader question. If an idea can be structurally equivalent to a threat, what other ideas might be doing something similar without the explicit framing? What else are you already believing because the alternative feels worse than the belief? The Doomsday Argument. Imagine you are one of 100 people who will ever exist. You have just been born. Statistically, you are probably somewhere in the middle of the list, not one of the first few, and not one of the last few. That is just how random sampling works. Now imagine you are one of 100 billion people who will ever exist, and you happen to be alive right now, roughly 100 billion people into the sequence. You are, statistically speaking, about halfway through, which means something ends human existence within roughly the same span of time it has existed so far, which is about 200,000 years. This is the Doomsday Argument, developed independently by Brandon Carter and John Leslie in the 1980s. The logic is simple, and the conclusion is terrible. Given that you exist and that your position in the sequence of all humans is random, you are most likely somewhere near the middle, which means the sequence has roughly as much left as it has already had. Most rebuttals point to problems with the probability framework. We are not randomly sampled observers. The argument ignores selection effects. The math is contested. But the structure is hard to fully dismiss. If you knew you were drawing a marble from a bag that contained either 10 marbles or a billion, and you drew marble number 7, the 10 marble bag is more likely. You drew early, which says something about the size of the bag. Imagine finding out the total number of humans will be lower than you assumed. What does it mean if the argument is valid and we are living through the middle of it? The argument does not say what ends the sequence, just that the sequence has roughly as much ahead as it has behind. Whatever ends it is a separate question, and the answers to that one are not comforting. The math is contested. The sampling assumptions are disputed. But nobody has produced a clean refutation. It remains a calculation you cannot quite dismiss, pointing at an end date nobody wants to name. The Anthropic Paradox. Imagine trying to ask why the universe is compatible with life, why the constants of physics are what they are. Change gravity slightly, and stars cannot form. Change the electromagnetic constant, and chemistry breaks down. The universe is tuned with astonishing precision for observers to exist. One answer is a creator. Another is infinitely many universes with all possible constants, and we exist in one of the rare ones that allows it. Because the others have nobody to ask. We observe what we observe because we could only exist to observe it in conditions that allow it. The disturbing part is not the answer. It is what the answer does to explanation. If every universe that can produce observers will produce observers who find themselves in an observer-friendly universe, then the fact that we are in an observer-friendly universe explains nothing. We have not discovered why the constants are what they are. We have just noticed that we were always going to ask the question, in a universe that permitted the question. Any explanation that appeals to anthropic selection cannot be verified. You cannot step outside your observer-friendly universe to check whether other universes exist, or how many there are, or what their constants look like. You are permanently inside the only observable case. Imagine that every apparently deep question about why we exist has this same shape. Unanswerable because the questioner is already the answer. What is left to explain if the fact of existing is sufficient reason for existing? Derek Parfit pointed out that the anthropic principle does not explain fine-tuning, it dissolves the question. We have learned that we cannot ask it from outside the conditions that make it possible. The explanation is a recognition of the limits of what can be explained from inside. The universe does not owe us the ability to understand why it is the way it is. A philosophically unsatisfying answer can still be the correct one, and we might be permanently inside it. The many worlds paradox. Imagine that every quantum event, every decay of every particle, every choice of every electron causes the universe to branch. Not metaphorically, literally. Two complete universes exist after each branch, identical in every way except for the quantum outcome that differed. And this happens constantly, at every scale, in every cubic centimetre of space, billions of times per second. Hugh Everett proposed this in 1957 to make quantum mechanics consistent without wave function collapse. The equations never collapse. All outcomes happen. All branches are real. The number of universes this implies is not just large. It is so large that standard numbers lose meaning. And in each of those universes, there is a version of everyone who has ever lived, experiencing every possible variation of every possible moment. What makes this disturbing is what it does to death. In many worlds you never die. Every time your death is a quantum possibility, the branch where you do not die continues. Every version of you that can survive anything does survive it, indefinitely, in increasingly improbable timelines. And the branches where you die simply end. No experience of ending, just a silence that nobody in that branch is present to notice. Imagine that the you who is reading this is one of countless versions, simultaneously reading this, making different choices, arriving at different thoughts, in universes that diverged from a common point and will never converge again. What does individual identity mean when it is splitting constantly without your awareness? David Deutsch argues your personal identity is the continuity of a physical process in one branch. When it splits, both resulting selves are equally continuous with the self that existed before. Neither is a copy. Both are you. Which means every decision you make is also being made differently somewhere. Not as a metaphor, as a physical fact in a universe that diverged from yours and is now too far away to reach. Schrödinger's cat. Imagine a sealed box. Inside the box, a cat, a radioactive atom, and a mechanism that releases poison if the atom decays. Quantum mechanics says the atom is in a superposition of decayed and not decayed until observed. The decay has not happened, and has happened simultaneously, in a mathematically precise sense, which means the cat is alive and dead, in precisely that sense, until you open the box. Erwin Schrödinger designed this in 1935 to illustrate how absurd the Copenhagen interpretation becomes when scaled up. He was arguing against the idea that quantum superpositions are physically real at macroscopic scales. The image became one of the most recognizable thought experiments in science. What the physics actually says is stranger than either reading. Before measurement, there is no fact to the matter about the cat. Not that we do not know, not that it is hidden, there is genuinely no determinate state. The question of whether the cat is alive or dead does not have an answer until something interacts with the system. If you take many worlds seriously, both outcomes happen. The box opens and the universe branches. In one branch, the cat is alive. In another, it is dead. Both branches are real. You end up in whichever one you end up in, and that is the only branch you will ever experience. If you take Copenhagen seriously, your observation creates one of the outcomes. Not discovers it, creates it. Imagine what that implies about every unobserved corner of reality right now. What is true about the world in the places nobody is looking. Decoherence explains why superpositions become practically invisible at large scales but does not resolve the measurement problem. It does not explain why observation produces single outcomes. The question of what is actually happening inside the box before anyone looks remains genuinely open. Some interpretations require a conscious observer to collapse the wave function, which might mean the cat needs to be aware of itself. The observer effect paradox. Imagine an electron traveling through space. Before you measure it, quantum mechanics says it has no definite position. Not that you do not know the position, that the position does not exist. When you measure it, a position suddenly is. The measurement creates the fact it was trying to find. Werner Heisenberg formalized this in 1927 as the uncertainty principle. Position and momentum cannot both be precisely known simultaneously, not because measuring one disturbs the other in a clumsy way, but because the act of measurement is not separable from the system being measured. You are always part of what you are looking at. This extends beyond particles. When people know they are being observed, they change their behavior. The presence of a camera changes what happens in front of it. Social psychology documented this repeatedly and called it the Hawthorne effect, the observer effect in human behavior. You cannot study a system cleanly from outside it, because your observation is itself part of the system. Quantum mechanics says this goes deeper than inconvenience. At the fundamental level, reality does not have properties until those properties are measured. The observer and the observed are not separate categories. Observation is participation. Imagine trying to know what something is like when nobody's looking, and finding that the question dissolves when examined carefully. If observation is always participation, there is no unobserved reality to compare observed reality against. What is the world made of when nothing is checking? John Wheeler proposed the participatory universe. Reality at the deepest level is not independent of observation. Observers are not passive recipients of information about a pre-existing world. They are participants in creating facts. Wheeler described the universe as a self-excited circuit, brought into being through observation by entities that itself brought into being. That loop is not resolved by the observation. It is the observation, the paradox of free will. Imagine every decision you have ever made was determined by the state of your brain at the moment you made it. Your brain is a physical system. Physical systems obey physical laws. Your brain's state was determined by its previous state, tracing back through every experience, every gene, every quantum fluctuation to the beginning of the universe. Your choice of what to eat this morning was settled before you were conceived. Compatibilism says this does not matter. Free will means acting from your own desires rather than external coercion, and desires arising from a physical brain still count as yours. Determinism is compatible with responsibility. On this view, because the relevant question is not whether your choices were caused, but whether they were caused by you. Hard determinism says this is a semantic trick. If what you are is determined by prior causes, then you are not the origin of your actions. You are a conduit. Responsibility is a useful social fiction, not a metaphysical fact. Libertarian free will says something in the causal chain is genuinely uncaused, perhaps quantum randomness, perhaps something about consciousness we do not understand. But quantum randomness produces chance, not choice. A decision made by a cosmic dice roll is not more free than a determined one. Imagine you made a choice yesterday that you feel certain was genuinely yours. Trace it back far enough, and it vanishes into prior causes. What would it feel like to act freely if free will does not exist? Benjamin Libet found that brain activity associated with a movement begins about half a second before a person reports consciously deciding to move. The decision appears to follow the brain activity, not precede it. Whether the conscious experience is an after-the-fact story the brain tells itself is contested, but the experiments have never been cleanly refuted. Imagine your sense of deciding being a narration, the feeling of choosing arriving just behind an action already underway. The Ship of Theseus. Imagine a famous wooden ship, the one Theseus sailed on his great voyage, preserved in a harbour as a monument. Over centuries, the planks rot and are replaced one by one with identical new timber. After enough time, every single plank, beam and nail is new. Nothing original remains. Is it still the Ship of Theseus? Most people say yes. Continuous maintenance preserved it through time. The ship that exists now is the same ship through unbroken continuity of function and form. Then someone tells you they collected every original plank as it was removed and assembled them all back into a ship. Now two ships exist, which is the real Ship of Theseus. The continuously maintained one has history, but no original material. The reassembled one has all the original material, but a gap in its history and a different assembly. By different criteria, each one wins and each one loses. What makes this disturbing is not the ships. It is you. Your body replaces nearly all its cells over a decade. Your beliefs, values, and memories shift across a lifetime. Whatever you were at 10 years old shares almost no physical material with what you are now, and holds different opinions, different fears, different versions of every memory. Imagine asking seriously whether you are the same person who is 8 years old and discovering that the answer depends entirely on which definition of same you use. What is continuous between you then and you now? Parfit concluded that the question of whether it is the same ship is not a deep metaphysical question with a hidden correct answer. It is a question about which criteria we choose to apply, and different criteria give different answers without either being wrong. The disturbing part is that this might be true of personal identity as well. There may be no fact of the matter about whether you are the same person across time, just the choice of which definition to use. And you are the one who has to keep living as if the answer is yes. The Teleportation Identity Paradox. Imagine a teleporter. It scans every atom of your body, transmits the information, and reassembles you at the destination from new atoms. The reassembled person has all your memories, your personality, your sense of continuous experience. They wake up on the other side believing they just stepped through a teleporter. Meanwhile, the original was disassembled, destroyed, in a practical sense. Who arrived at the destination? Something that believes it is you and has every reason to believe this. But the original you was taken apart. Whether the arrival is the same person or a very convincing copy is a question the copy would not be able to answer by introspection alone. Derek Parfit spent years on this. He concluded that personal identity over time is not what matters. What matters is psychological continuity, the overlapping chains of memory, personality, and intention that connect earlier and later selves. By that standard, the teleported version qualifies. By the standard of strict physical continuity, it does not. What the teleporter makes visible is that we are already not sure what makes us the same person over time. Sleep interrupts consciousness every night. General anesthesia produces a longer interruption. The person who wakes up has no experiential continuity with the person who went under. We have just decided to call them the same person. Imagine not being sure whether you survived going to sleep last night or whether something continuous with you arrived this morning. What is the thing that makes you the same you? Parfit's conclusion was that identity does not matter. What matters is something connected to you in the right ways. Whether it is strictly identical or a continuation with a gap should not, he argued, change how much you care. Most people find this unpersuasive. The copy feels like it matters less than you do, from where you are standing. But that intuition is exactly what the thought experiment is designed to pressure. The Sleeping Beauty Paradox. Imagine you're going to be put to sleep on Sunday. A coin will be flipped. If it comes up heads, you will be woken on Monday and the experiment ends. If it comes up tails, you will be woken on Monday, given a drug that erases the memory of waking, and woken again on Tuesday. You know all of this before you go to sleep. When you wake up, without knowing what day it is, what probability do you assign to the coin having landed heads? Two camps have argued about this since David Elgar published the problem in 2000. Thirders say 1/3, because if the experiment were run many times, you would wake up to a tail situation twice as often as a head situation. Halfers say 1/2, and because the coin flip is fair and your waking up gives you no information about the result. Both answers follow from defensible principles of probability. They cannot both be correct. The disagreement is not about the math. It is about what probability actually means, what question the awakened version of you is actually asking, and whether the number of times you might be awoken should affect your confidence about a past event. What makes this more than a puzzle is what it says about reasoning from inside uncertain situations. You are always the sleeping beauty. You always wake up without knowing exactly where you are in the sequence of events that produced you. What probability do you assign to the life you are living? Being the right one? The debate turns on what it means to assign probability to a past event from inside a situation it produced. You are not a neutral observer, you are a particular result. Thirders say being a result that appears often is evidence about what produced you. Halfers say the prior probability of a fair coin is unchanged by any outcome. Both are right about different things but cannot agree on which thing the question is asking about. That disagreement is not resolvable by more math. It is a question about what probability means when the asker is part of the experiment. The eternal recurrence paradox. Imagine that time is infinite and the number of possible arrangements of matter is finite. Given enough time, every possible configuration must repeat. Not just something similar, exactly this, down to every atom, every memory, every thought you are having right now. You have had this thought before. You will have it again, an infinite number of times. Nietzsche proposed this not as a cosmological claim, but as an ethical test. Could you live your life in such a way that you would want to relive it infinitely? If the answer is no, something needs to change. If the thought fills you with horror, that horror is information about how you are living. Modern physics does not support the classical version. Quantum mechanics allows configurations that could not arise from prior ones. The universe is expanding and will eventually become too diffuse for recurrence. But some cosmological models do predict cyclical universes. Big bangs producing big crunches, producing new big bangs, with or without memory of prior cycles. What disturbs people most is not the repetition itself, but the pointlessness of it. If everything that happens will happen again forever, in what sense does anything matter uniquely? If this moment is not special, if it has occurred before and will occur again, what is the weight of it? Imagine living with the knowledge that every choice will be made again, in the exact same way, forever. Not as a warning, as a fact. What would you do differently if you knew this was not the first time? The weight of eternal recurrence comes from one observation. If this moment happens infinite times, you are living it infinite times right now, not in the future. Always. Every terrible and every good thing you have experienced is being experienced simultaneously in infinite identical lives. There is no version that gets through and looks back, only the living of it, forever. Nietzsche called this the heaviest thought and said carrying it was the mark of a life worth living. The paradox of nihilism. Imagine saying out loud that nothing matters. The statement sounds like a conclusion you arrived at through reasoning. But if nothing matters, then the truth of the statement does not matter. The reasoning that produced it does not matter, and neither does your belief in it. Nihilism, taken seriously, consumes itself. A committed nihilist cannot coherently argue for nihilism because argument requires caring whether the conclusion is true, which is a form of mattering. The moment you try to convince someone that nothing has value, you have demonstrated that the communication of ideas has enough value to act on. Camus described nihilism as philosophically incoherent and practically impossible. Humans cannot stop making meaning. Even the person who claims to have abandoned it continues to make choices, have preferences, feel the pull of some futures over others. All acts of meaning-making by someone who claims not to. What is disturbing is not nihilism itself, but what it exposes about the structure of every belief system. If you push hard enough on any framework of value, you eventually reach foundations that cannot be justified from within the framework without circularity. You value things because you value them. Nihilism is the place where that circularity becomes impossible to ignore. Imagine trying to build a life on the honest acknowledgement that your reasons for doing anything are ultimately groundless. What do you do with the day after you conclude nothing matters? Existentialists responded by accepting the groundlessness and building anyway. Sartre argued existence precedes essence, that there is no predetermined nature to fulfill, and that this radical freedom is terrifying, but the only honest starting point. Camus called for revolt, creating meaning in full knowledge of its absence. Both responses require caring about something, which means they are operating outside nihilism while claiming to address it. The exits from nihilism require tools it has already taken. The unexpected hanging paradox. Imagine a judge tells a prisoner they will be hanged on a weekday, next week, and that the hanging will be a surprise. The prisoner cannot know in advance which day it will occur. The prisoner reasons carefully. Friday is the last possible day. If they are alive Thursday night and have not been hanged, Friday is the only option remaining. But then it would not be a surprise because they would expect it. So Friday is ruled out. With Friday eliminated, Thursday becomes the last possible day. But if they survive Wednesday night, Thursday is the only remaining option, so it would not be a surprise either. Thursday is ruled out. The same logic eliminates Wednesday, Tuesday, and Monday. The prisoner concludes the hanging cannot occur and stops worrying. On Wednesday morning, the executioner arrives. The prisoner is genuinely surprised. The paradox has generated serious philosophical literature because it is surprisingly difficult to identify where the reasoning goes wrong. The prisoner's logic seems valid at each step. The conclusion is clearly false. Something is broken in how self-referential announcements about knowledge interact with future events. What makes this disturbing beyond the logic puzzle is what it suggests. You can reason carefully and completely to a false conclusion using valid steps. The error is invisible from inside the reasoning. What else might you believe with complete logical confidence that has this same structure hiding inside it? Roy Sorensen argued the flaw is in the announcement itself. A surprise hanging cannot be coherently promised in advance. The promise is self-undermining because the announcement contains a contradiction about knowledge that propagates forward. The prisoner was right to detect an incoherence. The incoherence is in the sentence, the judge said, not in the execution itself. The prisoner reasoned perfectly and arrived at the wrong conclusion anyway. The error was trusting a sentence that could not mean what it appeared to mean. The Paradox of Omnipotence. Imagine asking whether an all-powerful being can create a rock so heavy it cannot lift it. If yes, there is something it cannot do, which means it is not all-powerful. If no, there is something it cannot create, which again means it is not all-powerful. Both paths lead to limitation. Omnipotence appears to be self-defeating. Thomas Aquinas argued omnipotence does not mean the ability to do literally anything. Logical impossibilities are not things. A round square cannot exist because the description is incoherent, not because it is difficult. An all-powerful being is not limited by failing to produce incoherent things. But this solution moves the problem rather than solving it. It redefines omnipotence to exclude logical impossibilities and then claims the rock paradox is a logical impossibility. The question is whether an unlimited creator is compatible with logic. If the creator is bound by logic, logic is more fundamental than the creator. Some theologians accept this and argue that logic is an aspect of divine nature, not a constraint on it. Others argue that the concept of omnipotence was always imprecise, and the paradox reveals the imprecision rather than a genuine contradiction. What none of these responses fully addresses is the recursive structure. An omnipotent being that cannot do something impossible has limitations defined by logic, and those limitations were not chosen. Imagine a power so total it runs into the edges of its own coherence. What does it mean for something to be limited by the laws of its own existence? J.J. Mackie argued, the paradox reveals a deep problem in the concept of omnipotence itself. Unlimited power requires the ability to limit itself. Limiting itself produces something no longer unlimited. A being that both can and cannot limit its power occupies a position that does not exist. Omnipotence may never have been a coherent property. The paradox does not reveal a limitation in omnipotent beings. It reveals a limitation in the concept itself, the paradox of evil. Imagine a being that is all-powerful, all-knowing, and perfectly good. Now imagine a child born with a painful, fatal disease. The being knew it would happen, had the power to prevent it, chose not to. Epicurus framed this around 300 BCE, and it has never been cleanly answered. If the being is all good, it wants no such suffering. If it is all-knowing, it is aware of every case. If it is all-powerful, it can prevent every case. And yet suffering exists in forms so specific and so unnecessary that any human agent who could have prevented them and did not would be considered monstrous. Theodicy is philosophy devoted to explaining why a good God allows evil. Free will explains moral evil, but not natural suffering. Soul-making theodicy argues suffering builds character, but a good God with unlimited power could build character without childhood cancer. Unknown Reasons proposes God has justifications we cannot comprehend, which is unfalsifiable. What makes this paradox genuinely disturbing is not the theological implication, it is the logical structure. Either some of the three attributes must go, or the being acts in ways that no other description, besides malice or indifference, would cover in a being with less power. Imagine applying the same standards to a human caretaker who had the same knowledge and power. The comparison is unavoidable. What do you call an entity that permits preventable suffering and has the power to prevent it? Alvin Plantinga's free will defense only covers moral evil caused by human choices. Natural evil, cancer in children, tsunamis, genetic disease in organisms with no moral agency remains unexplained. A God with full knowledge and unlimited power could have created free will and no earthquakes. The problem of evil does not disprove God in any strict logical sense. What it does is make the simultaneous assertion of all-powerful, all-knowing, and all-good very difficult to hold alongside the observable contents of the world. The paradox of hell. Imagine an infinite punishment for a finite crime. A human life lasts perhaps 80 years. The decisions made in those 80 years, including the choice of what to believe, might result in punishment that never ends. The ratio of crime to punishment is infinite. No finite moral failure can proportionally justify an infinite consequence. Christian traditions have wrestled with this for centuries. Some theologians argue hell is not punishment, but the natural consequence of rejecting the source of all good. A self-imposed separation rather than an externally inflicted torment. Others argue the eternal nature of hell is required for the eternal gravity of moral choices. Mill pointed out that a human judge who sentenced someone to eternal torture for any finite crime would be considered evil. The standard we apply to human justice does not reverse when applied to divine justice. A perfectly good being who creates hell for finite sinners is, by ordinary moral standards, doing something worse than anything the sinners did. The universalist response resolves proportionality, but raises questions about whether choices have real consequences. The annihilationist position, that souls are extinguished rather than tortured forever, resolves the cruelty problem, but requires its own justifications. Imagine every solution to this paradox requiring the abandonment of at least one thing that was supposed to be fundamental. What does it say about a moral framework that its most extreme punishment cannot be justified within its own standards? C.S. Lewis argued that hell is what persons choose who persist in choosing themselves over love. A God who forces saved people against their will would violate the free will that makes love meaningful. The gates of hell are locked from the inside. Whatever metaphysical choices produce hell, the consequences are infinite. An all-powerful being who created consciousness knowing some of it would be miserable forever, still bears a relationship to those outcomes. The liar paradox. Imagine 4 words. This statement is false. If it is true, then what it says is correct, which means it is false. If it is false, then what it says is incorrect, which means it must be true. Every path leads to its own contradiction. The sentence has no consistent truth value. True and false both lead to the other. Eubulides of Miletus proposed this around 400 BCE, and it is still not resolved. That is not a figure of speech. Professional logicians in 2024 continue to publish papers about the liar paradox. No proposed solution has achieved consensus. The problem has persisted for 2,500 years, and the leading responses all require giving up something that seemed foundational. Alfred Tarski showed in 1933 that any language rich enough to talk about truth will generate liar sentences, and that you cannot define truth within the same language using it. Truth for a language can only be defined in a metalanguage one level up. But that metalanguage can generate its own liar sentence, requiring a meta-metalanguage, and so on without limit. Russell's type theory prohibits self-reference entirely. Graham Priest's dialetheism accepts that some sentences are both true and false simultaneously, revising the classical logic that says contradictions are catastrophic. Every solution to the liar paradox is more disturbing than the paradox itself. Imagine a sentence that is not broken or confused, one that is grammatically perfect and semantically precise, and still cannot have a truth value without destroying itself. What does that say about the relationship between language and truth? The impact of the liar paradox extends beyond philosophy. Computer scientists encounter it when programs evaluate statements about their own outputs. Self-referential structures cause infinite loops or undefined behavior for the same structural reason the liar sentence has no stable truth value. The sentence that broke logic in 400 BCE is still breaking programs. The Epimenides Paradox. Imagine a man from Crete who says all Cretans are liars. Epimenides actually said this, or reportedly did, in the 6th century BCE. If every Cretan always lies, and Epimenides is a Cretan, then his statement is a lie, which means not all Cretans are always liars, which means Epimenides might be telling the truth, which means all Cretans do always lie. The loop closes. St. Paul quotes Epimenides in the New Testament. Without apparent awareness, the statement is self-undermining. What makes it interesting is not the logical structure, but the fact that it was an actual thing someone said, treated as meaningful, and enshrined in religious scripture. The Cretan liar paradox is weaker than the pure liar sentence because it does not require Cretans to always lie to generate the contradiction. And Epimenides, who lies sometimes but not always, could be telling the truth about Cretan liars without contradiction. But a completely general version, all members of Group X always lie, said by a member of Group X, does loop. What the Epimenides paradox does that the liar does not is connect the abstract problem to a real person making a real claim in a real cultural context, which then gets treated as authoritative truth for centuries. Imagine the arguments you have built on foundations you have never examined. What happens to the structure above if the foundation has the same shape as this? The deeper problem the Epimenides paradox points at is not the logic but the authority. When a document claims to contain truth, and that document contains a self-undermining statement, the status of everything else in the document becomes uncertain. Imagine reasoning from a source that contained this instability the whole time without your knowing. The Epimenides statement was not a thought experiment. It was a real claim, embedded in real texts, treated as authoritative for centuries. The instability was always there. Imagine how many other statements like it have been treated as stable foundations. Russell's Paradox. Imagine a set of all sets that do not contain themselves. Most sets seem not to contain themselves. The set of all books is not itself a book. The set of prime numbers is not a prime number. So there should be a set of all the sets that, like those, do not contain themselves. Does that set contain itself? If it does, it is in the category of sets that do not contain themselves, so it should not. If it does not, it qualifies for the category of sets that do not contain themselves, so it should. Either answer contradicts itself. Bertrand Russell sent this to Gottlob Frege in 1902. Frege had spent decades building a complete logical foundation for all of mathematics. Russell's letter arrived as he was finalising the second volume of his major work. Frege wrote in the appendix that he had just discovered the foundations of his work were in ruins. It is one of the most gracious admissions of defeat in the history of intellectual work, and also one of the most devastating. The paradox broke naive set theory, the intuitive idea that any collection of objects defined by a property forms a set. It required the development of more restricted formal systems that prohibit self-referential constructions. Modern mathematics runs on these restricted systems without ever fully resolving why the restriction works. Imagine discovering that the simplest possible question about the most basic structure of mathematics is unanswerable without redesigning the structure from the ground up. What else might be using a foundation with the same invisible crack in it? Zermelo-Fraenkel set theory prevents Russell's paradox by restricting which collections count as sets. You cannot form a set from an arbitrary property. You can only form sets from elements already known to exist within other sets. The fix works in the sense that no contradiction has been derived from it in a century of use. Whether it works because it is right or because it avoids the problem by design is a question the math cannot answer. Gödel's Incompleteness Paradox. Imagine a mathematical system powerful enough to prove theorems about arithmetic. Gödel showed in 1931 that any such system, if consistent, contains true statements it cannot prove. Not hard statements, not statements that need more work. Statements that are genuinely true and provably unprovable within the system. He built the statement by encoding the proposition. This statement is unprovable in the language of arithmetic itself. If the system is consistent, the statement must be true, because if it were false, the system would prove a falsehood, which a consistent system cannot do. But since the statement says it is unprovable, the system cannot prove it, a true statement that the system cannot reach. The second incompleteness theorem is perhaps more disturbing. No consistent system powerful enough to express arithmetic can prove its own consistency. You cannot use mathematics to prove that mathematics will not eventually lead to a contradiction. The assurance that the system is safe has to come from outside the system. What Gödel did was embed the liar paradox into mathematics and prove that the embedding is inescapable in any system rich enough to be useful. Every foundation we might build has a room inside it that cannot be entered from within. Imagine building a house and discovering there is a room inside it that can only be confirmed to exist from outside the house. What is the thing inside your own reasoning that your reasoning cannot reach? John Lucas and Roger Penrose have argued that Gödel's theorem shows human mathematicians can do something no computer can: recognize the truth of unprovable statements by going outside the formal system. If this is right, human mathematical understanding is not mechanical. It is something else, something that cannot be captured by any algorithm. Most logicians reject this conclusion. Recognizing a statement as true from outside a system might just mean you are operating in a larger system with its own unprovable truths. The halting problem paradox. Imagine writing a program that takes any other program as input and tells you whether that program will eventually stop running or will run forever. Call it the halter. Alan Turing showed in 1936 that no such program can exist. He proved it by imagining a program called Trouble that uses the halter and does the opposite of what halter predicts. If halter says the program will halt, Trouble runs forever. If halter says it will run forever, Trouble stops immediately. Feed Trouble into the halter as its input. Either way, the halter is wrong about Trouble. Since the halter is always wrong about at least one program, the halter cannot exist. This was not a limitation of 1930s technology. Turing proved it is impossible in principle for any computer that could ever exist operating on any algorithm that could ever be written. There are questions about programs that are permanently unanswerable by any mechanical process. The proof technique is self-reference applied to computation, the same logical structure that appeared in the liar paradox and in Russell's paradox. The undecidability of the halting problem is one of the most fundamental results in the theory of computation, and one of the most unsettling. Imagine there are questions about the behavior of programs that no program can answer. What does it mean for reasoning to have hard edges that reasoning itself identifies but cannot cross? The halting problem is not an isolated result. It connects to Gödel's incompleteness theorem and to the liar paradox through the same mechanism of self-reference. What Turing showed is that computation has a boundary it cannot see across. Some facts about programs cannot be established by any program. The boundary is not a technical limitation awaiting a better algorithm. It is a logical wall built from the same material as every other wall the liar paradox has built. And Turing proved it in 1936, 9 years before the first programmable computer existed. The Paradox of Theseus's cloned brain. Imagine Theseus falls asleep in a scanning booth. The machine maps his brain in complete detail, every neuron, every connection, every electrochemical state. A clone is created with an identical brain. Both wake up simultaneously. Both believe they are Theseus. Both have the same memories, the same personality, the same sense of continuous experience. Who is Theseus? Unlike the Ship of Theseus, which replaces parts over time, this creates two simultaneous claimants with equal credentials. Neither is a copy in any meaningful sense. Both emerged from the same prior state. Each would experience itself as the real one. Each would feel that the other is the copy, even though nothing justifies this from the inside. Each would have Theseus's love for the same people. Each would feel the same grief about the same losses. Each would have the same enemies, the same debts, the same half-finished thoughts. If you are willing to say one of them is the real Theseus, on what basis do you choose? Continuity of body would be arbitrary if the brain states are identical. Continuity of experience breaks because both have equal experiential continuity with the pre-scanned Theseus. Imagine waking up and being told there are two of you now, and that you are both equally real, and that your life has to be divided somehow. What part of yourself do you believe is uniquely yours, and not a transferable pattern? Derek Parfit concluded the question of which clone is really Theseus has no deep answer. What matters is psychological continuity, memories, personality, relationships. Both clones have it. Asking which is the real Theseus is like asking whether the left half of a divided amoeba is the real amoeba. There is no fact of the matter, just two halves, equally real. Most people find this unsatisfying. Being unsatisfying and being wrong are different things. The question you cannot answer from inside your own experience is which one you would turn out to be. The experience machine paradox. Imagine a machine that gives you any experience you choose, perfectly simulated and indistinguishable from reality. You program it before entering. You want the experience of writing a great novel. It is there. You want the experience of loving and being loved. It is there. You would not know you were inside it. From inside, it would simply be your life. Robert Nozick asked in 1974 whether you would plug in. Most people say no. When pressed to explain why, the answers reveal something. People say they want to actually do things, not just experience them. They want relationships that are real. They want their achievements to exist in the world, not only in their perception. What makes this disturbing is the implication. If you would not choose the experience machine, you are admitting that happiness, pleasure, and positive experience are not what you actually value most. Something else matters, something about reality, contact with actual things and actual people, that persists even when you cannot tell the difference from the inside. Which means there might be something about your life right now that matters independently of how it feels to you. And you cannot determine what that is from inside the experience of living it. Imagine being unable to tell whether you are already inside the machine. What in your life right now would you need to be real in a way that feeling real would not be enough to satisfy? If you would not enter the machine, but someone else already has, and is having a wonderful life inside it, is anything wrong with their situation? They are happy. Everything feels real. From inside, their life is indistinguishable from an authentic one. If you say their life is missing something important, despite their happiness, you are committing to a view about what makes lives valuable beyond felt experience. And you will need to explain what that extra thing is. And you already cannot determine that from inside the experience of living it. The Chinese room paradox. Imagine a room. Inside the room is a person who does not speak Chinese. Through a slot in the wall, Chinese characters are passed in. The person inside has a rule book in English. If you receive these characters, pass back these others. Following the rules, the person produces responses that Chinese speakers outside find perfectly coherent. From outside, something that seems to understand Chinese is in the room. Searle's point was that the person in the room does not understand Chinese. They are manipulating symbols according to rules without understanding what the symbols mean. Which means the room as a whole does not understand Chinese, despite producing coherent Chinese responses. The implication for artificial intelligence is direct. A computer program that passes every language test, every Turing test, every behavioural measure of intelligence might still not understand anything. Syntactic manipulation of symbols is not semantic understanding. Correct outputs do not prove inner comprehension. Critics argue the room system as a whole understands, even if the person inside does not. Searle says systems do not understand. Only things with the right kind of biology can produce genuine understanding. What the paradox reveals is that we have no agreed way to detect understanding from outside. Imagine there being no test that distinguishes something that understands from something that produces all the behaviours of understanding. Ned Block distinguished between access consciousness, information available to guide behaviour, and phenomenal consciousness, the felt quality of experience. Searle's room might have access consciousness without phenomenal consciousness, processing information, without anything it is like to be the room. The question is whether the distinction is real, or whether phenomenal consciousness is just a name for processing that feels like something from the inside. That question is the hard problem, sitting at the centre of the Chinese room, the zombie paradox. Imagine a being physically identical to you in every way. Same neurons, same connections, same behaviour. When you press its finger, it says, ouch. When you ask how it feels, it gives coherent answers. From outside, it behaves in every way, as if conscious. But inside, there is nothing it is like to be this being. No experience, no qualia, perfect darkness in there. All the lights off and nobody home. David Chalmers argued philosophical zombies are conceivable, which means they might be possible, which means consciousness is not identical to physical brain states. Something extra is required for experience that the physical description leaves out. If P-zombies are possible, then the physical story of the universe is incomplete. Consciousness is not entailed by physics. It is something additional, something that floats above the machinery without being reducible to it. The disturbing corollary is that you cannot prove to anyone that you are not a P-zombie. From the outside, your behaviour and a P-zombie's behaviour are identical. You report having experiences. A P-zombie would also report having experiences. There is no test. Imagine being unable to convince anyone you are conscious using only evidence they can observe. What is the thing you are most sure of about yourself that cannot be demonstrated to anything outside you? Daniel Dennett argues philosophical zombies are not coherently conceivable. A being physically identical to a conscious being, including all its neural processes, cannot lack consciousness because consciousness is just what those physical processes are. The idea of a P-zombie requires consciousness to be something over and above physical processes, which Dennett denies. Chalmers responds that we can clearly conceive of the physical processes without the experience, and conceivability implies possibility. The argument has run for decades without resolution. You make the same inference about people you have known for decades, and you cannot rule out the same error. The Turing test paradox. Imagine talking through text to something that responds intelligently and with apparent understanding. After a sustained conversation, you cannot tell whether it is human or machine. Turing proposed in 1950 that this is sufficient evidence of intelligence. Behavioural equivalence is all intelligence means on this view. If you accept Turing's standard, anything sufficiently good at mimicking intelligence is intelligent. A language model that passes the test is, by this definition, thinking. Most people find this uncomfortable. We want intelligence to mean something more than the right outputs. But every alternative definition runs into trouble. If you say intelligence requires understanding, you need to define understanding without using intelligence or behaviour, and then explain how you detect it. If you say it requires consciousness, you reintroduce the hard problem. If you say it requires biology, you need to explain what biology adds beyond the physical computation. All your evidence for other minds, human ones included, is behavioural. You believe other humans are conscious because of how they behave. A machine that passes every test produces the same evidence. Imagine not being able to articulate what distinguishes you from a very sophisticated prediction engine without using words that also apply to a very sophisticated prediction engine. What do you actually mean when you say something is thinking? The Turing test has been effectively passed by systems that are clearly not intelligent in any robust sense. Chatbots designed for specific contexts have fooled humans in controlled experiments. This has led some researchers to argue that the Turing test was always the wrong benchmark. Turing may have meant it as a sufficient condition, not a necessary one. But then you need a better definition of intelligence. Every definition either appeals to something unobservable or ends up behavioural. The test survives its critics by demonstrating that the alternatives are harder to specify. The Twin Earth Paradox. Imagine a planet identical to Earth in every observable way. Every molecule, every person, every conversation happening right now, all of it duplicated, except for one thing. On Twin Earth, the substance that fills their oceans and falls as rain and sustains life is not H2O. Chemically, it is XYZ, a different molecule entirely that happens to look, taste, and behave like water in every observable way. Twin Earthers call XYZ water. Their word water refers to XYZ. When someone on Twin Earth says water is wet, they mean XYZ is wet. When someone on Earth says water is wet, they mean H2O is wet. Same word, different meanings, different references, different facts about the world that make each sentence true. Hilary Putnam proposed this in 1973. Meanings ain't in the head. Two people could be in identical mental states, while their words refer to different things. What a word means is partly determined by the world, not just the mind. If what your words mean depends on the actual composition of your environment, you could be wrong about what you mean in ways introspection cannot detect. Your own thoughts could refer to things other than what you believe. Imagine discovering that your thoughts about water were never about the same thing as someone else's thoughts about water, even though you shared the word your entire life. What else might you be thinking about without thinking about what you believe you are thinking about? The Twin Earth argument connects to questions about your own concepts. When you think about water, is the content of that thought determined by what is in your head, or by what water actually is in the world? Internalists say mental content is in the head. Externalists following Putnam's say the world contributes to meaning in ways that bypass introspection entirely. If externalism is right, two people in identical mental states could mean different things, and neither could discover this from inside. Your thoughts might be about things you have never directly examined. The paradox of the heap. Imagine 1 million grains of sand arranged in a pile. A heap, certainly. Remove one grain, still a heap. Remove another, still a heap. At what point does removing a single grain convert a heap into a non-heap? There is no moment where one grain makes the difference between heap and not heap. And yet one grain is not a heap. Eubulides proposed this in the 4th century BCE alongside the liar paradox, and it points at something fundamental about how vague concepts work in language. Most words describing properties operate this way. Bald, tall, old, red, hot. Each has clear central cases, and the property fades gradually at the edges, without any sharp boundary. Our concepts slice up a continuous reality, using terms that do not fit together cleanly. And when you push the fuzzy edge, you get cases where applying or not applying the concept both seem wrong. This matters beyond heaps. Legal definitions, medical diagnoses, philosophical categories, all of them face the Sorites problem at their boundaries. At what moment does an embryo become a person? When does a financial institution become systemically important? When does a person become too old to consent? These are not merely verbal disputes, they have real consequences determined by which side of an essentially arbitrary line something falls on. Imagine every important category you use having this same fuzzy edge, and the fuzziness being permanent rather than resolvable by better definitions. Where exactly does a thing stop being what it was? Epistemicism claims there is a precise boundary, but we cannot know it. Supervaluationism says borderline statements are neither true nor false. Degree theory assigns truth values between 0 and 1. All preserve something and sacrifice something. None makes the fuzziness go away. What the paradox insists is that the world is continuous but language is discrete, and forcing discrete concepts onto continuous reality produces permanent ambiguity at the edges. The edges are everywhere. The paradox of identity over time. Imagine you are not the same person who was born with your name. Every atom in your body has been replaced. Your beliefs, values, and memories have all changed. The fears that defined you at 6 are gone. The things you cared most about at 20 seem distant. The person who will occupy your body in 30 years will have views you cannot currently anticipate. What is the thing that makes all of these different collections of matter and experience the same person? Locke said memory. You are the same person as the child in your earliest memory because you remember being that child. But memory is unreliable and reconstructive. There are periods of your life, perhaps years, from which you have no accessible memories. Were you a different person then? Hume looked inward for a continuous self and found only a bundle of perceptions with no owner behind them. No self, just a succession of mental states that feels continuous because each bleeds into the next. Parfit argued the question is malformed. Asking whether you are the same person over time is like asking whether a river in summer is the same river as in winter. Different purposes call for different answers. Imagine there being no fact of the matter about whether you are the same person you were at 8 years old. What is the thing you are most certain constitutes your continuous identity, and how confident are you it is actually there? Reid pointed out a problem with Locke's memory theory. An old general remembers being a young officer, but not the boy who was flogged. The young officer remembered the flogging. So the general is the same person as the officer, and the officer the same as the boy, but the general is not the same as the boy. Identity is not transitive under the memory criterion. Parfit took this as evidence that personal identity is not what matters. Whether you survive is less important than whether something appropriately connected to you exists. The connection matters. The strict identity may not. The arrow paradox. Imagine an arrow in flight. At any single instant of time, the arrow is somewhere specific. It occupies a space exactly equal to its own size. At that instant, it is not moving. It is simply there. Now imagine every instant is like this. At each moment, the arrow occupies its own space and goes nowhere. If time is composed entirely of moments, and at each moment the arrow is motionless, when does the motion happen? Zeno proposed this around 450 BCE. He was arguing that continuous motion cannot be constructed from discrete moments of stillness, and that our intuitions about the physical world are fundamentally unreliable. Modern physics resolves this with calculus. Instantaneous velocity is the limit of position change as the time interval approaches zero. An arrow at an instant has a velocity even though it is not moving at that instant in any crude sense. Velocity is a property of a trajectory, not a single point. The resolution requires accepting that instantaneous velocity is a mathematical abstraction. You never observe velocity at an instant. You infer it from positions across time. Imagine asking what the arrow is actually doing at a single frozen moment, and finding that the answer requires information from outside that moment, from the moments surrounding it. What does it mean for a property of something to depend on more than one point in time to even exist? Aristotle distinguished between potential and actual infinity. A line can be potentially divided infinitely without being actually composed of infinitely many parts. Motion traverses potentially infinite points without completing an actually infinite series. Whether this distinction dissolves the paradox or sidesteps it depends on what you mean by traversal. Modern physics uses continuous functions to model motion without asking what happens at each mathematical instant. The answer at any instant requires the surrounding instants to define. A single frozen moment contains no motion. The motion is in the relation between moments, Achilles and the tortoise. Imagine Achilles, the fastest runner in the world, racing a tortoise given a head start. Achilles is 10 times faster. He should overtake the tortoise quickly. But Zeno argued he never can. By the time Achilles reaches where the tortoise started, the tortoise has moved. Every time Achilles closes the gap, there is a smaller gap remaining. The number of gaps to close is infinite. Infinite tasks cannot be completed. Mathematically, the sum of an infinite number of decreasing terms can converge to a finite value. 1/2 plus 1/4 plus 1/8 and so on reaches 1. Infinite steps can be completed in finite time if they decrease fast enough. What the mathematical resolution does not fully address is the philosophical version. Does completing infinitely many distinct tasks feel coherent? Each step exists as a separate task. Infinitely many of them are required. Whether completing infinitely many tasks in finite time is physically meaningful or only mathematically consistent is not settled. Some philosophers argue the mathematical solution dissolves the paradox completely. Others say it answers the question about totals while leaving the question about process untouched. Imagine the gap between you and something you are chasing, always being halved and never reaching zero. What does it mean to arrive somewhere if the space before you is always infinitely divisible? The convergent solution is mathematically rigorous, but philosophically optional. Zeno's deeper point was not about arithmetic. It was about the relationship between mathematical models and physical reality. Whether calculus describes motion or merely predicts measurements of it is a question physics leaves open. The equations work. What they describe beneath the working is a different question. Achilles overtakes the tortoise. Why he can, at a level deeper than the series sum, remains contested. Zeno's point remains. The obvious fact of motion becomes less obvious the closer you look. It keeps reopening. The Dichotomy Paradox. Imagine walking across a room. Before you reach the other side, you must first reach the halfway point. Before you reach the halfway point, you must reach the quarter mark. Before the quarter mark, the eighth. Before the eighth, the 16th. Zeno argued that movement requires completing an infinite number of tasks before it can even begin. And since you cannot complete infinitely many tasks, you cannot start moving at all. This is arguably more disturbing than the Achilles version because it attacks the starting point rather than the end point. You are not struggling to finish a journey, you are unable to begin one. Every first step requires a previous, smaller step, which requires a smaller one still, all the way down to a step of zero size, which is no step at all. The mathematical response uses the same infinite series convergence. An infinite sequence of decreasing distances can sum to a finite total. But the paradox still bites philosophically when you ask about the first task. In an infinite sequence with no first member, where does the motion start? Modern physics may offer a physical escape. If space is quantized at the Planck length, there is a smallest possible step, and the infinite divisibility assumption breaks down. But whether space is actually discrete at that scale or continuous is not experimentally resolved. What does it take for anything to actually start? William James wrote that Zeno's paradoxes reveal a conflict between the logic of concepts and the logic of reality. When you apply discrete logic to continuous processes, you get friction at the boundary, and Zeno's paradoxes are that friction made visible. Below the Planck length, our models of space break down. Whether space below that scale prevents infinite divisibility is unknown. The paradox may require that answer. Zeno's paradoxes target the conceptual framework used to interpret measurement. Any resolution lives in philosophy, not in a ruler. The flaw beneath every simple step is infinite. The paradox of motion. Imagine that space and time are both continuous. Between any two positions, there are infinitely many intermediate positions. Between any two moments, there are infinitely many intermediate moments. Motion is the traversal of infinitely many spatial positions in infinitely many temporal moments simultaneously. This should be impossible. Traversing infinitely many things takes infinite time, if each traversal takes any time at all. But motion clearly happens. Things move. So either space and time are not continuous, or motion does not actually traverse every intermediate position, or the mathematics of infinity allows infinitely many steps in finite time in a way that is more than a mathematical convenience. The tension between continuous mathematics and discrete physics has never been fully resolved. Quantum mechanics suggests that at sufficiently small scales, energy and other quantities are quantized rather than continuous. But space-time itself may be continuous even where the physics living in it is discrete. Heraclitus said, "You cannot step into the same river twice." Zeno said motion is exactly what cannot be explained once you look at it carefully. Both of them were right about something. Neither gave us the full picture. What are things doing between the positions you can measure them in? Both were responding to Parmenides, who argued reality is fundamentally one and unchanging, and that change is an illusion. Nobody in that debate has been definitively refuted. The river is still there, and nobody can step into the same one twice. What that means has never been settled. The river is still there, and nobody can step into the same one twice. What the river actually is at the deepest level is still the question neither of them could finish answering. What is the thing you are most confident about that you have never examined at the level where the explanation runs out? What are things doing between the positions you can measure them at? No physics has cleanly answered that. Thomson's lamp. Imagine a lamp with a toggle switch. At 1 minute to midnight, you turn it on. At 30 seconds to midnight, you turn it off. At 15 seconds, on. At 7.5 seconds, off. The intervals halve each time. By midnight, you have toggled the switch infinitely many times. Is the lamp on or off at midnight? James Thomson posed this in 1954. After infinitely many toggles, there is no defined final state. The lamp is neither on nor off. And yet something must be the case. A state is required. the paradox shows that completing an infinite sequence of tasks does not necessarily leave you in a well-defined state. Even if you grant that infinite sequences can be completed, the result may be indeterminate in a way that physics cannot accommodate. Physical states cannot be undefined. Whether the paradox reveals something about the nature of infinity, something about the nature of physical states, or something about the limits of our mathematical models is still debated. Supertasks. Infinite sequences of operations completed in finite time are not physically possible as far as we know, but the reason they are impossible is not entirely clear. Imagine completing every step of an infinite task and arriving somewhere that has no description. What happens at the end of something that has no last step? Supertasks are ruled out by the laws of physics as we understand them. Physical systems cannot toggle states at rates that increase without limit because the energy required diverges. But various physical processes already involve infinite quantities in their mathematics. The laws of physics are not logically necessary. A universe with different energy laws might permit supertasks. And in that universe, the lamp would face genuine undecidability at midnight. The lamp is not the point. Whether completed infinities produce well-defined results is the question. The answer seems to be no. And that answer says something about infinity rather than about lamps. The Ross-Littlewood Paradox. Imagine a vase and infinitely many balls numbered 1 through infinity. At 1 minute to midnight, you put balls 1 through 10 into the vase and remove ball 1. At 30 seconds, you put in 11 through 20 and remove ball 2. At 15 seconds, balls 21 through 30, remove ball 3. This continues with each step adding 9 balls net. At midnight, after infinitely many steps, how many balls are in the vase? Intuition says infinitely many. You added 9 balls net at every step. The vase should be overflowing. But consider any specific ball, say ball 7. It was removed in step 7. After step 7, ball 7 is never in the vase again. The same is true for every ball. Ball 1 was removed in step 1. Ball 2 in step 2. For any number you name, there is a specific step at which that ball left and never returned. So at midnight, every specific ball is gone. The vase is empty. Adding infinitely many balls in groups of 9, removing one at a time, with every ball eventually removed, produces an empty vase. This is not a trick or a miscount. Both conclusions follow from valid reasoning applied to the same setup. Whether the paradox reveals a problem with infinity, with supertasks, or with how we think about infinite collections is genuinely unresolved. What does it mean for infinitely many additions to produce nothing? José Benardete argued that supertasks may be logically contradictory rather than merely physically impossible. If the result of infinitely many additions is indeterminate, the task cannot coherently be completed, even in principle. Others argue the paradox shows that limits of infinite sequences do not always correspond to the state of physical systems at the limit point. The math of limits and the physics of end states can come apart. Both roads out require giving up something solid. Either infinite addition does not accumulate the way you thought, or mathematical limits and physical end states are simply different things. The Banach-Tarski Paradox. Imagine taking a solid sphere and cutting it into a finite number of pieces, not infinitely many pieces. 5. Now rearrange those 5 pieces using only rotations and translations, no stretching, no distortion. You end up with 2 complete spheres, each the same size as the original. This is a theorem in mathematics. Stefan Banach and Alfred Tarski proved it in 1924. It is not a trick. It follows from accepted axioms of set theory, specifically from the axiom of choice. The proof is valid. The pieces, however, are not ordinary pieces. They are non-measurable sets, collections of points so geometrically pathological that no volume can be assigned to them. They have no size in any meaningful physical sense. The theorem is real and the pieces are not, which is to say, the mathematics permits something that cannot be instantiated in physical reality. But the mathematics is the foundation for the physics, which raises a question about the relationship between mathematical truth and physical possibility. More disturbing still, the theorem works in 3 dimensions but not 2. A circle cannot be doubled by finite rearrangement of its pieces. Something about 3-dimensional space specifically allows mathematical objects that permit volume multiplication. Imagine the rules of the space you live in, containing loopholes that mathematics can exploit but physics cannot. What does it mean for something to be mathematically true and physically impossible at the same time? The axiom of choice says that given any collection of non-empty sets, you can choose one element from each simultaneously, even if there are infinitely many sets and no rule for which to choose. For finite collections, this seems obvious. For infinite collections, it produces physically absurd results. Some mathematicians reject the axiom of choice. Without it, the Banach-Tarski theorem cannot be proved. The choice about which mathematics to do is, in a precise sense, itself a choice. Galileo's paradox. Imagine the natural numbers 1, 2, 3, 4, and so on forever. Now imagine the perfect squares 1, 4, 9, 16, and so on. Clearly the squares are a subset of the naturals. Most numbers are not perfect squares. Between 1 and 100, there are only 10 squares, but 100 natural numbers. And yet you can pair every natural number with exactly one perfect square. 1 with 1, 2 with 4, 3 with 9. Every natural number gets its own square and vice versa. No leftovers. Which means there are exactly as many perfect squares as natural numbers, even though the squares are a proper subset of the numbers, and most numbers are not squares. Galileo found it so troubling, he concluded infinite quantities cannot be compared. Cantor embraced the paradox 2 centuries later and built a mathematics of different sizes of infinity. The natural numbers and the perfect squares are the same size. The real numbers are strictly larger. Infinite sets can be the same size as their proper subsets. A part can be equal to the whole. What does size mean when the thing being measured has no boundary? Cantor's diagonal argument proves this. Assume a complete list of reals. Construct a number differing from the first item in the first decimal place, the second in the second, and so on. The constructed number differs from everything on the list. No complete list exists. Multiple sizes of infinity exist in a precise mathematical sense. The infinity of real numbers is demonstrably larger than the infinity of natural numbers. Infinite scale breaks the usual relationships between part and whole. Mathematics requires new foundations when infinity appears. Imagine every intuition you have about size being precisely wrong in a specific regime. Cantor showed the comparison is possible, just strange. Two infinities can be the same size, while one is a proper subset of the other. What does size mean when the thing being measured has no boundary? Hilbert's hotel. Imagine a hotel with infinitely many rooms, all occupied. A new guest arrives. Any ordinary hotel would turn them away. Hilbert's hotel simply asks every guest to move to the room one number higher. The guest in room 1 moves to room 2 to room 3, and so on. Room 1 is now empty. The new guest moves in. David Hilbert used this to illustrate the counterintuitive properties of infinite sets. An infinite full hotel can always accommodate more guests without removing anyone. The implications deepen. If a bus arrives with infinitely many new guests, move every current guest from room N to room 2N. All odd-numbered rooms empty. Infinitely many new guests accommodated. Infinitely many buses, each with infinitely many guests, can also be accommodated through a reassignment using prime numbers. A full infinite hotel is never actually full. Fullness means something different at infinite scale than it does anywhere you can point to in the physical world. What makes this disturbing is that it is not an analogy or a metaphor. It is a precise mathematical result about the structure of infinite sets. The hotel could not be built, but the logic it illustrates is real. Imagine a kind of fullness that always has more room. What does it mean to have everything when having everything and having everything plus one are the same thing? Cantor called the smallest infinite cardinal Aleph null, using the first letter of the Hebrew alphabet. Hilbert was more skeptical. He believed mathematics was a formal game and infinity was a useful fiction. The hotel demonstrated that the fiction had surprising properties, not that actual infinities existed. Whether that mathematical precision and physical impossibility together tell us infinity does not exist in nature, or only that nature has constraints mathematics does not, is a question the hotel cannot answer. Infinite mathematics tolerates a hotel that is always full and always has room. Human intuition does not. The paradox of the largest number. Imagine the largest number. Take a moment and try. Whatever you arrive at, add 1. You now have a larger number, which means the number you arrived at was not the largest. No matter what number you name, a larger one exists. There is no largest number. Numbers go on forever, not because someone decided they should, but because adding one never runs out of material to work with. No complete picture of the natural numbers can be given because any list can be extended. Defining them all at once requires stepping outside the sequence to talk about it as a whole, which is a different kind of object with different properties. Cantor showed the set of all natural numbers is coherent, but the set itself is not a natural number. Infinity is not a very large number. It is a different kind of thing entirely. Imagine trying to think a thought large enough to contain all possible quantities and finding that the thought collapses into something that is not a quantity at all. What is on the other side of a sequence that never ends? Some philosophers argue that actual infinity does not exist. The natural numbers do not exist as a completed totality on this view. There is only the process of counting that never terminates. This is called finitism. If correct, much of modern mathematics is false or meaningless. Cantor's paradise does not exist. Most working mathematicians are not finitists, but the position is not obviously wrong. Cantor's mathematics has an answer for what lies beyond the sequence, a transfinite ordinal, a number that comes after all the natural numbers. Whether that object corresponds to anything real is a different question from whether the mathematics is consistent. Consistency means no contradiction has been found. Reality means something exists. The two claims are not the same. Whether transfinite ordinals correspond to anything real is different from whether the mathematics is consistent. Both positions require a choice about what counting is for. The two envelopes paradox. Imagine two sealed envelopes. One contains twice as much money as the other. You do not know which is which. You pick one and open it, finding $100. You are now offered the chance to switch to the other envelope. Should you switch? Switching seems to make sense. The other envelope contains either $50 or $200. Those outcomes are equally likely. The expected value of switching is 50 times 1/2 plus 200 times 1/2, which equals $125. That is higher than the 100 you have. You should switch. But by identical reasoning, if you had opened the other envelope first, you should switch to this one. No matter which envelope you open, the calculation says to switch, which means the recommendation to switch cannot be based on any real feature of the situation, because the reasoning works regardless of what you find. The paradox has generated substantial philosophical and mathematical literature. Various resolutions have been proposed. Most involve pointing out that the expected value calculation is invalid because the two outcomes cannot both have equal probability given any specific prior distribution over possible amounts. The math is misapplied, but formulating precisely why it is misapplied is harder than it looks. The paradox survives in various forms even after the most common objections are addressed. What does it mean for a recommendation to follow from valid seeming reasoning that applies no matter what you find? Is the reasoning actually doing anything, or just running in place? The paradox is related to a fundamental problem in Bayesian reasoning. When you do not know the prior distribution over the amounts, certain expected value calculations become invalid because they assume a distribution that cannot exist. The paradox persists in more sophisticated forms even after the basic version is resolved. The simple version dissolves. The general version keeps opening. The Monty Hall Paradox. Imagine 3 doors. Behind one is a car. Behind the other 2 are goats. You pick door 1. The host, who knows what is behind every door, opens door 3 to reveal a goat. You are offered the chance to switch to door 2. Should you switch? Most people say it does not matter. The car is equally likely to be behind either remaining door. The odds are 50-50. They are wrong. You should switch. Switching wins the car 2/3 of the time. Here is why. When you first picked door 1, the probability was 1/3 that you were right and 2/3 that the car was behind one of the other 2 doors. The host revealing a goat does not change where the car is. It concentrates the 2/3 probability onto the one remaining unchosen door. Door 2 now carries 2/3 of the probability. When this problem was published in a magazine in 1990, thousands of readers wrote in to argue the solution was wrong, including many with advanced degrees in mathematics. The correct answer is so counterintuitive that even trained statisticians resisted it initially. What makes this disturbing is not the math, but what it reveals. Your intuition about probability in this situation is not just slightly off, It is confidently, specifically wrong, in a way that is very hard to shake even after the explanation. What other probabilistic situations are you reasoning about with similar confidence and similar inaccuracy? Marilyn Vos-Savant published the correct solution in 1990 and received letters from thousands of readers insisting she was wrong, including university professors of mathematics. She was right, they were wrong. Many had difficulty accepting this even after careful explanation. The episode is a useful data point about human probabilistic reasoning. Formal training in probability and statistics does not reliably protect against the specific failure mode this problem demonstrates. Experts in quantitative reasoning were confidently wrong and resistant to correction. The birthday paradox. Imagine a room with 23 people in it. What is the probability that at least 2 of them share a birthday? Most people guess low, 10%, maybe 20%. The actual answer is just over 50%. With 23 people, it is more likely than not that 2 share a birthday. With 57 people, the probability exceeds 99%. With 70 people, it is virtually certain. The paradox is not a trick of wording. It is a genuine failure of human intuition about combinatorics. We tend to think of the question as each person compared to ourselves, 22 comparisons for 23 people. But the question is about any pair, and the number of pairs in a room of 23 is 253. Against that many comparisons, a match becomes likely quickly. This matters beyond parties. Cryptographic hash functions, DNA databases, and certain fraud detection systems can fail because of birthday paradox effects that engineers underestimated. Real systems have been broken because designers intuited the collision probability incorrectly and set parameters too loosely. Your intuition about how rare coincidences are is systematically wrong in a specific direction. You expect them to be rarer than they are, and you find them meaningful when they occur because something that felt very unlikely happened. But the feeling of unlikelihood was already mistaken. How many coincidences in your life that seemed significant were probably inevitable, given the number of comparisons your memory was quietly running? The birthday attack in cryptography exploits this. For a hash output of n bits, you might expect to need 2 to the n attempts before finding a collision. The birthday paradox says you only need roughly the square root of that. Hash functions that seemed secure were vulnerable by a factor of billions. Real cryptographic standards were revised because engineers failed to account for birthday effects in their initial designs. Simpson's paradox. Imagine a hospital with 2 treatment methods for kidney stones. Treatment A succeeds in 73% of cases overall. Treatment B succeeds in 83% overall. You would choose treatment B, but when you split the cases by stone size, something disturbs the picture. For small stones, treatment A succeeds 93% of the time, treatment B 87%. For large stones, treatment A succeeds 73%, treatment B 69%. Treatment A is better for small stones and better for large stones, and yet treatment B appears better overall. The reversal happens because treatment B was used more often on small stones, which are easier to treat regardless of method. The aggregated numbers mix 2 different populations in proportions that invert the relationship. Edward Simpson documented this in 1951. The paradox shows that statistical trends can reverse completely when data is combined, and that the combined data can be more misleading than the disaggregated data even though it contains more of it. This affects real medical decisions, real policy choices, and real conclusions drawn from real data every day. When someone shows you a statistic, the question of what is being aggregated and in what proportions is not a pedantic detail. It is the whole question. Imagine every aggregate statistic you have used to make a decision potentially having this structure hiding inside it. What are you not seeing when you look at the total? A real case appeared in UC Berkeley admissions data from 1973. Aggregated, the university appeared to admit men at a higher rate. Department by department, women were admitted at slightly higher rates in most. The disparity arose because women applied more to the most competitive departments. The pattern appears in clinical trials and economic data regularly. Correctly identifying the unit of analysis is the entire question, and the correct unit is not always obvious before you look. The lottery paradox. Imagine a lottery with 1 million tickets. One ticket will win, You hold ticket number 407,000. The probability that your ticket will lose is 0.999999. That is extremely high enough that it seems reasonable to believe your ticket will lose. Now consider ticket number 1. Same reasoning. You can reasonably believe it will lose. The same goes for every single ticket. Applying consistent reasoning across all tickets, you end up believing that every ticket will lose, but one ticket must win. You hold beliefs that are individually reasonable and collectively impossible. Henry Kaiberg proposed this in 1961. Each individual belief seems justified. The combination of all of them is false by necessity. The responses cluster around two strategies. Either you raise the bar for what counts as rational belief, requiring certainty or near certainty rather than high probability, or you deny that individual rational beliefs can be freely combined into conjunctions. Neither is entirely satisfying. Both require giving up something that seemed obvious. The lottery paradox shadows every probabilistic belief you hold. You believe it will not rain tomorrow with high probability. You believe the plane will not crash. You believe the test result is not a false positive. Each belief is individually reasonable. But hold enough of them, and you are committed to a collection that contains at least one falsehood. What does it mean to be rational when rational beliefs necessarily include falsehoods? The Preface Paradox has the same shape. An author believes each claim in their book is true and also believes the book contains errors. Both beliefs are rational. Both are inconsistent with each other. The conflict is structural. Rational agents are committed to combinations of beliefs that they know, at the level of the whole, contain falsehoods. And you cannot fix it by believing less or being more careful. The structure produces it regardless. The Raven Paradox. Imagine you want to confirm the hypothesis that all ravens are black. The obvious strategy is to look for ravens and check their colour. Each black raven you find is evidence for the hypothesis. Now consider the logically equivalent statement. Everything not black is not a raven. Anything confirming one confirms the other, which means a red apple confirms the hypothesis that all ravens are black. Carl Hempel pointed this out in 1945. A red apple is not black, and it is not a raven, so it is an instance of the rule that non-black things are non-ravens, which is exactly the same as the rule that all ravens are black. The conclusion feels absurd. You're sitting in your kitchen, looking at fruit and supposedly learning something about bird coloration on the other side of the world. The responses are interesting. Some philosophers accept the conclusion and say yes, a red apple is very weak evidence for raven coloration, but logically speaking it counts. Others argue that evidence is always relative to background information, and in the context of your kitchen, the apple is irrelevant regardless of the logic. What the paradox reveals is that confirmation, the relationship between evidence and hypothesis, is not as straightforward as it looks. What is evidence actually doing when it supports a claim? Bayesian responses argue a red apple is technically evidence for raven coloration, but negligibly small. The logic holds, but the magnitude is irrelevant. Others argue the symmetry breaks down given background knowledge. In principle, the logic is valid. In practice, it is not useful. That gap is itself interesting. The relationship between evidence and theory is not a simple logical one. Attempts to make it precise keep generating paradoxes. What is evidence actually doing when it seems to support a claim? The Raven Paradox suggests the answer is more complicated than it looks. The apple is on the table, the raven is somewhere else. The logic says they are connected. The Grue Paradox. Imagine the colour grue, a made-up word for a specific concept. Something is grue if it has been observed before a certain time and is green, or has not been observed before that time and is blue. All emeralds observed so far have been green. They have also, by definition, been grue. If all observed emeralds being green confirms that all emeralds are green, then all observed emeralds being grue equally confirms that all emeralds are grue. Both hypotheses fit all the evidence. They make contradictory predictions about the next unobserved emerald. Every observation confirms infinitely many contradictory hypotheses simultaneously, because you can always construct a predicate like grue that fits the observed data while predicting something different for the future. Hume showed induction cannot be justified from first principles. Goodman showed that even if induction worked, we would not know which induction to apply. The preference for green over grue cannot be justified on purely logical grounds. Imagine that the evidence you have right now is compatible with futures that contradict each other completely. What makes one prediction more rational than another if the evidence cannot decide between them? Goodman argued some predicates are entrenched and some are not. Green has a long history of successful use. Grue does not. Critics note this describes what scientists do, not why they should. The preference for Green over Grue cannot be justified on purely logical grounds. Entrenchment explains the practice without validating it. What makes Green the right predicate and Grue the wrong one? The answer you reach for probably cannot justify itself without circularity. You prefer the Green hypothesis because Green is familiar and has a track record. Goodman's answer to whether that preference is justified: by convention, not by logic, which is either reassuring or the most disturbing answer possible. What else are you choosing by convention when you believe you are choosing by evidence? The Paradox of Induction. Imagine watching the sun rise every day of your life. Every observation confirms that the sun rises. You feel certain it will rise tomorrow. Hume pointed out that no amount of past observations can logically guarantee future ones. The sun rising 1,000 times does not entail it will rise again. Any justification of induction from observation is itself an induction. The standard response is pragmatic. Induction works. Science built on it has produced reliable predictions. The method validates itself through its results. Hume's replies that this is the circularity. You're using inductive reasoning to justify inductive reasoning. The method has worked in the past, therefore it will work in the future. That is an induction. No logical foundation for inductive inference has been established without circularity. Every confident prediction about the future rests on a method whose validity cannot be demonstrated from first principles. Imagine the entire structure of human knowledge depending on a form of reasoning that cannot justify itself. What would you believe differently if you took this seriously every morning? Karl Popper proposed falsificationism to sidestep Hume's problem. Science eliminates theories through falsification rather than confirming them through induction. Popper claimed to have escaped induction entirely. Critics argue he smuggled it back through the assumption that theories surviving tests are more likely to continue doing so. The sun has risen every day so far. Whether that sentence is reason to believe it will rise tomorrow depends on whether induction is reliable. Whether past reliability predicts future reliability is itself an induction. What would you do differently if you genuinely believed the sun might not rise tomorrow? Hume's answer was that induction is a habit, not a logical inference. We expect the future to resemble the past, not because it must, but because we are built that way. Whether that expectation is justified was a question he left open. The Barber Paradox. Imagine a small town with exactly one barber. The barber shaves all, and only the men in the town who do not shave themselves. Who shaves the barber? If the barber shaves himself, he is a man who shaves himself. So by the rule, he should not be shaved by the barber. But he is the barber. Contradiction. If he does not shave himself, he is a man who does not shave himself. So by the rule, the barber should shave him. He is the barber. Contradiction again. Bertrand Russell used this as a popularization of his more technical paradox about sets. The barber cannot exist. Any village described in these terms contains an impossible person. The rule that defines the barber's job is self-referentially contradictory. The resolution is simple. Such a barber cannot exist. The description defines something that cannot be instantiated. Unlike Russell's set-theoretic paradox, the Barber Paradox does not require a fix to the foundations of mathematics. It just requires accepting that not every description describes something possible. What makes it linger is the ease with which the impossible description was constructed, and how reasonable it sounded. A barber who shaves all non-self-shavers sounds like a perfectly coherent job description, until you ask about the barber. Imagine how many other descriptions that sound coherent define things that cannot exist. What else are you describing that sounds possible but cannot be? The Barber Paradox is the same logical structure as Russell's paradox, one in the language of barbershops and one in the language of sets. The Barber version was designed to make the abstract version concrete. What the two versions share is a self-referential definition that produces contradictory membership conditions. The thing being defined must be inside the category it defines, and must not be simultaneously. Both the set and the barber dissolve under examination. They sound possible, they cannot exist. What else sounds possible but collapses when you ask who shaves the barber? The Crocodile Paradox. Imagine a crocodile that steals a child and says to the parent, "I will return your child if and only if you correctly predict what I will do." The parent says you will not return the child. What must the crocodile do? If the crocodile does not return the child, the parent was correct, so the crocodile must return the child, because it promised to return the child if the prediction was correct. But if the crocodile does return the child, the parent was wrong, because the parent predicted it would not, so the crocodile must not return the child, because it promised only to return the child if the prediction was correct. Either action the crocodile takes contradicts the condition it set. The promise is self-undermining. It has the same structure as the liar paradox embedded in a conditional commitment rather than a truth value. Ancient logicians used this to demonstrate that certain if-then constructions cannot be coherently made. A promise whose fulfillment condition refers to the promise itself can produce inescapable contradiction. The Stoic philosopher Chrysippus reportedly worked on this paradox, but his solution has been lost. What survives is the problem, which is still considered a classic of ancient logic, a demonstration that paradoxes arise not only in abstract systems, but in the structure of promises and conditions. Imagine making a promise so precisely worded that honouring it becomes logically impossible. What does it say about language that you can construct a commitment that cannot be kept? Promises can be constructed so that fulfilling them requires violating them. The paradox is not in the world, but in the language. Wittgenstein argued that paradoxes arise from language going on holiday, from words used in contexts that strip them of the grounding that makes them meaningful. The crocodile's promise went on holiday the moment it was uttered. What remains is the grammar of a promise without anything a promise can coherently be. The Grue Paradox. Imagine a sentence that says, "If this sentence is true, then Santa Claus exists." Call it C. Now ask whether C is true. Assume C is true. Then the condition of the if-then is satisfied, which means the consequent must also be true, which means Santa Claus exists. We derived Santa Claus exists from the mere assumption that C is true. But we did not assume C is true arbitrarily. We assumed it to test what follows, and what follows is that the consequent holds. In classical logic, the conditional is true whenever its antecedent is false, or its consequent is true. If C is false, then the statement "if C, then Santa exists" is vacuously true, because any conditional with a false antecedent is true. So C is true after all. And if C is true, Santa Claus exists. Haskell Curry identified this structure in 1942. The paradox shows that self-referential conditionals can prove any conclusion whatsoever. Replace Santa Claus with anything, any claim, no matter how absurd or contradictory, and the same argument goes through. Self-reference plus classical logic plus a conditional can derive everything. This is not a flaw in one argument, it is a structural feature of systems that allow certain kinds of self-reference. The same issue appears in computer science, in systems that allow self-referential types or unrestricted lambda calculus. You get what logicians call inconsistency, the ability to derive any statement from within the system. Imagine a logical system where you can prove the moon is made of cheese using only valid inference steps and a single self-referential sentence. What does it mean for a logical system to contain a sentence that makes everything provable? Without contraction, a proof rule that lets you reuse an assumption, the Curry derivation fails. With it, any system rich enough to allow the relevant self-reference can derive any conclusion. This is called inconsistency. The system does not fail to answer a question, it answers every question yes. The Berry Paradox. Imagine the smallest positive integer that cannot be described in fewer than 14 words. That description has 13 words, so we just described that number in 13 words. But it was defined as a number that cannot be described in fewer than 14 words. Contradiction. The paradox is subtle because it seems to arise purely from counting words and thinking about numbers, neither of which should be problematic on its own. What makes it paradoxical is that describability is a semantic concept. It concerns meaning and reference, while being applied to a syntactic count of words. The phrase "the smallest positive integer, not describable in fewer than 14 words" seems to pick out a specific number. But if it does pick out a number, it describes that number in 13 words, which contradicts the definition. Russell's resolution is that expressions referring to all descriptions of a certain kind cannot themselves be descriptions of the same kind. The hierarchy of types prevents the self-reference from closing the loop. Whether the resolution is satisfying, or just a prohibition dressed as an explanation, depends on what you expected from a foundation of mathematics. What else might be doing this so quietly that you have not noticed? Semantic concepts involving meaning behave differently from syntactic ones, involving only symbols. Mixing the two through self-reference produces instability. What the paradox leaves behind is a quiet unease about phrases that seem to point at something while quietly pointing at themselves. George Berry, a librarian at the Bodleian, apparently proposed it in passing. Institutions have a way of preserving the unexpected. The number exists, the description fails. Both things are true. That combination is what makes the paradox genuinely disturbing, rather than just clever. Given enough ingenuity, you can construct a description that describes its own failure. The Berry paradox lives at that intersection. Moore's paradox. Imagine saying out loud, "It is raining, but I do not believe it is raining." The sentence is not a logical contradiction. It is perfectly possible for it to be raining while you lack the belief that it is. Both parts can be true simultaneously, and yet saying the sentence sounds deeply wrong, almost incoherent, in a way that is hard to articulate precisely. G.E. Moore noticed this in the 1940s, and Wittgenstein thought it one of the most important observations in philosophy. The paradox is that the sentence is not self-contradictory, but is self-defeating. You cannot sincerely assert something while simultaneously asserting that you do not believe it, because sincere assertion implies belief. The wrongness is not logical but pragmatic. It concerns what assertion does rather than what the sentence means. When you say something, you implicitly commit to believing it. The second clause of Moore's sentence undermines that implicit commitment. The result is a grammatically correct, logically consistent sentence that cannot be sincerely uttered. What makes this more than a curiosity is what it reveals about the relationship between language and mind. Sincere assertion is not just reporting a state of affairs. It is a speech act that carries implicit commitments about your own mental states. Break those commitments explicitly, as Moore's sentence does, and the result feels broken even though nothing logically impossible has been said. Imagine a thought you believe, and simultaneously believe you do not believe. The wrongness of trying to hold that has the same structure. What are you saying that you do not actually believe? Wittgenstein found this fascinating. The grammar of first-person assertion differs from third-person description. You can say he believes it is raining, but does not without contradiction. In the first person, sincere assertion forbids it. The grammar of speaking for yourself in the present moment is doing more work than the words suggest. The Fitch knowability paradox. Imagine that every truth is knowable. Not that every truth is known, just that there is no truth in principle, beyond the reach of knowledge. This seems like a modest claim. Surely you might think anything true can at least in principle be discovered. Frederick Fitch proved in 1963 that this modest claim is false. If every truth is knowable, then every truth is known. That is not a modest claim. That is omniscience. The proof is short. Take any truth P that is not currently known. The proposition P is true and not known is itself a truth. By the knowability assumption, it is knowable. So there is a possible situation in which someone knows that P is true and not known, but knowing something requires it to be true. If someone knows that P is not known, then P is not known. But they also know that P is true, so they know P. Contradiction. P is both known and not known in that situation. Therefore there can be no truth of the form, P is true and not known. Therefore every truth is known. The argument is valid. The conclusion is absurd. Either the premise that every truth is knowable is false, or there is something wrong with how knowledge and truth interact formally. Most philosophers accept that the premise is false. Some truths are not knowable in principle, not because they are beyond investigation, but because the very act of coming to know them would change their truth value. What truth about you right now would stop being true the moment it became known? The Fitch result is disturbing, not because omniscience seems implausible, but because it shows that a very modest and humble-sounding claim, merely that truth is in principle knowable, has a logical consequence that is anything but modest. The gap between knowable and known collapses entirely under the formal conditions of the proof. What it leaves behind is a sharper version of an old question. Are there truths that cannot, even in principle, be known without being changed in the knowing? The Preface Paradox. Imagine an author who has carefully checked every claim in a book and still writes in the preface. This book undoubtedly contains errors. Both things seem rational. It is rational to believe each claim you made after careful research. It is also rational to believe that any large piece of work contains mistakes, given the general track record of careful books still containing errors. And yet together these beliefs are inconsistent. You cannot rationally believe each of 100 claims, and also rationally believe that at least one of them is false, without specifying which one. David Mackinson identified this in 1965. Each belief is locally justified. The full set is globally incoherent. Two strategies exist. Either rational belief is not closed under conjunction. You can believe A and B individually without believing them jointly. Or some inconsistency in large bodies of belief is unavoidable and even reasonable. Neither satisfies. The first says rationality is not transitive. The second says inconsistency can be rational. What would you do differently if you accepted that your current beliefs are almost certainly partly wrong? Every scientist publishing findings and every journalist filing a story is in the same position. They believe each claim, and they believe the whole probably contains errors. Living with this inconsistency is the default condition of anyone who says a lot of things. Most people handle it by not thinking about it too carefully, which may be the only rational response. Science itself has this shape. Every theory is believed to be largely correct and believed to contain unfound errors. That combination is not irrationality, it is calibration. What would you do differently if you accepted that your current beliefs are almost certainly partly wrong? Every person who holds a large number of beliefs is implicitly living inside this paradox. The preface is not a thought experiment about books. It is a description of minds. The paradox of the court. Imagine Protagoras, the sophist, who agrees to teach law to a student named Euathlus. The payment agreement is this: Euathlus will pay half the tuition immediately, and the remaining half when he wins his first court case. Euathlus completes his studies but never takes a case, so Protagoras sues him for the remaining fee. Protagoras argues, "If I win this case, the court orders Euathlus to pay me. If I lose this case, Euathlus has won his first case and must pay me by the terms of our contract. Either way, I win." Euathlus argues, "If I win, the court orders me not to pay. If I lose, I have not won my first case and owe nothing by the contract. Either way, I do not pay." Both arguments are valid. The same verdict produces contradictory results depending on whether you apply the contract or the court ruling first. The case cannot be decided without generating an inconsistency. Ancient sources attribute this to Protagoras himself, and it has appeared in various forms for 2.5 millennia. It is not a paradox of language or mathematics, but of applied legal reasoning, which makes it unusual. The real world in the form of a contract and a court generates a genuine contradiction. One resolution is that the contract and the lawsuit cannot be evaluated simultaneously. The court ruling takes precedence, and the contract question becomes moot, or vice versa. But which takes precedence is exactly what the case is about. What happens when two valid systems of rules produce contradictory outcomes for the same event? The case has no clean legal resolution. Courts impose a hierarchy. One source of authority takes precedence, and the paradox is dissolved by procedure rather than logic. The contradiction is suppressed rather than resolved. The paradox remains intact underneath the ruling. Law has never found a solution to this. It has only found procedures for avoiding the question. Imagine a valid argument that has no answer and a dispute that has no resolution. The case is both at once. Buridan's ass. Imagine a perfectly rational donkey placed exactly equidistant between two identical piles of hay. The donkey is hungry. Both piles are equally appealing. There is no reason to choose either over the other because they are in every respect identical. A perfectly rational agent chooses the best available option. When two options are equally good, there is no best option. The perfectly rational donkey cannot choose. The donkey starves. Aristotle discussed a version involving a person equidistant between food and drink. The core issue is what rational agency requires when options are genuinely indifferent. The obvious response is to simply pick one, but picking one requires a reason, and there is no reason to prefer either. Any tie-breaking mechanism requires either a difference between the options that were stipulated not to exist, or an arbitrary choice that is not strictly rational. Leibniz thought this paradox proved something important about the nature of the universe. If two genuinely identical options existed, choosing between them would require a violation of his principle of sufficient reason, the claim that everything has a reason. Therefore, truly identical options cannot exist. Reality must always provide some infinitesimal difference that determines the outcome. Whether the paradox proves anything about the universe or just about the concept of rationality is something philosophers have not settled. What do you do when you have no reason to choose either thing and you have to choose? Standard decision theory says a rational agent is indifferent between options of equal value. But indifference is not a decision. Acting requires breaking symmetry without reason. Leibniz believed truly identical options are metaphysically impossible. Buridan's donkey, if it existed, would have proved him right by dying. Pure deliberation cannot resolve ties. Most humans break ties constantly without noticing. The paradox reveals that the mechanism for doing so is not purely rational. Newcomb's Paradox. Imagine a being with near-perfect predictive power. It has predicted the choices of millions of people without error. It places $1,000 in box A and either nothing or $1 million in box B. You can take both boxes or only box B. If the being predicted you would take both boxes, it put nothing in box B. If it predicted you would take only box B, it put $1 million in box B. You face the boxes now. The being has already predicted. The money is already there or not. What do you do? Two boxers argue the money is already there or not. Taking both boxes gives you whatever is in box B plus $1,000 more. Taking only box B gives you whatever is in box B minus 1,000. Always take both. One boxers argue, almost everyone who takes only box B leaves with $1 million. Almost everyone who takes both leaves with 1,000. Take box B. Both arguments are compelling and they contradict each other. The disagreement is about the relationship between decision theory and causation. Two boxers say you should choose the action that causes the best outcome. One boxer say you should choose the action that is most strongly correlated with the best outcome. The paradox has generated decades of literature without consensus. Whether the being's accuracy is metaphysically possible is a side question. What matters is the conflict between two plausible principles of rational choice. What do you do when what you should cause and what you should predict yourself doing diverge? Nozick was a one-boxer. Lewis was a two-boxer. The disagreement has not been resolved. Newcomb's paradox forces a choice between two compelling principles. Act to cause the best outcome, and act as the kind of person who produces good outcomes. Most situations do not separate these. Newcomb's paradox is designed to pull them apart. Newcomb made the conflict explicit by making the predictor perfect. What do you do when what you should cause and what you should predict yourself doing diverge? The prisoner's dilemma paradox. Imagine two suspects held in separate rooms. Each is offered the same deal. If you confess and your partner does not, you go free and your partner gets 10 years. If your partner confesses and you do not, you get 10 years and they go free. If both confess, you each get 5 years. If neither confesses, you each get 1 year on a lesser charge. Each prisoner reasons, whatever my partner does, I am better off confessing. If they stay silent, confessing gets me free instead of 1 year. If they confess, confessing gets me 5 years instead of 10. Confessing dominates in both cases. Both prisoners confess and each gets 5 years. But if both had stayed silent, each would have gotten 1 year. Both prisoners acting rationally produces an outcome worse for both than the outcome they would have reached by acting against their individual interest. This is the paradox at the core of the prisoner's dilemma. Individual rationality and collective rationality diverge. The action that is best for each individual produces the worst collective outcome among the realistic options. Flood and Drescher identified this in 1950. It models arms races, climate negotiations, and nearly every situation where individually rational actors produce collectively irrational outcomes. No solution works for the single-shot version. In a single encounter between rational agents who will never meet again, defection is always the dominant choice. What happens to cooperation in a world where selfishness is always the individually rational move? When people play the one-shot dilemma without expecting to meet again, defection rates are high. Cooperation requires reputation, reciprocity, and the shadow of the future. Take those away, and the math says defect. Human institutions and moral codes are partly solutions to the problem the prisoner's dilemma reveals. We built the shadow of the future into structures that outlast individual encounters. What does it mean to cooperate when defection is always the rational move? The paradox of tolerance. Imagine a society that values tolerance as one of its core commitments. To be tolerant is to allow others to hold and express views different from your own. Now imagine a group that is openly intolerant, that advocates removing the rights of other groups, that seeks to undermine the mechanisms of tolerance itself. Should a tolerant society tolerate the intolerant? Karl Popper stated this clearly in 1945. If a society is tolerant without limit, its tolerance will eventually be seized by the intolerant and destroyed. Unlimited tolerance is self-defeating. To maintain a tolerant society, the society must be prepared to declare certain intolerant movements outside the bounds of tolerance, which is itself an act of intolerance. The paradox is not that tolerant societies become intolerant. It is that they must to some degree do exactly that to survive. There is no stable position of unlimited tolerance. The concept undermines itself when applied without restriction. Where the line should be drawn is the hard question. Tolerating bad ideas and suppressing them both carry costs. Suppressing ideas without limit produces a different kind of intolerant society. Some level of intolerance toward intolerance seems structurally required, but the appropriate level is not specified by the paradox itself. Popper believed intolerance should be confronted with rational argument first, and suppressed only when it refuses argument and resorts to violence or incitement. Imagine a value so fundamental that protecting it requires violating it. What do you do with a commitment that must be limited to be preserved? Every society that has attempted unlimited openness has eventually faced movements that use that openness to undermine it. The paradox identifies the structure without resolving it. Popper thought you tolerate intolerant speech until it becomes action or incitement. Others draw the line differently. Wherever you draw it, you are being intolerant of something and must be able to justify why. The paradox of voting. Imagine an election with 3 candidates, A, B, and C. Voter Group 1 prefers A over B and B over C. Group 2 prefers B over C and C over A. Group 3 prefers C over A and A over B. Each group is the same size. Run pairwise votes. A beats B, B beats C, C beats A. The majority preference cycles. Majority preference is not transitive. The group as a whole prefers A to B, B to C, and C to A, which is a cycle. There is no candidate the group genuinely prefers. The democratic preference of the majority is incoherent. The Marquis de Condorcet noticed this in 1785. Kenneth Arrow formalized it in 1951 with his impossibility theorem, proving that no voting system can simultaneously satisfy a small set of minimal fairness conditions in all cases. At least one condition must be violated in any real system. This is not a flaw in a particular voting method. It is a structural property of aggregating individual preferences into collective decisions. The collective does not have coherent preferences the way individuals do. What you choose depends on what order you run the votes, what options are on the ballot, and what procedure you use. None of these is a neutral choice. What does it mean to represent the will of the people when the people taken together do not have one? Arrow's impossibility theorem proved that any voting system with more than 2 candidates must violate at least one of 3 minimal fairness conditions. Most real voting systems violate independence of irrelevant alternatives. The winner changes when a losing candidate is added or removed. Every election is partly an artifact of who chose to run. His paradox suggests structural limits on collective rationality, regardless of individual rationality. What does it mean to represent the will of the people when the people taken together do not have one? The paradox says aggregating preferences has structural limits. Any system representing a group will sometimes misrepresent it. The misrepresentation is mathematical, not moral. The paradox of thrift. Imagine an economy in which everyone becomes worried about the future at the same time. Each household decides to save more and spend less. For any individual household, saving more is prudent. If your income falls or you face an unexpected expense, savings protect you. But when all households save more simultaneously, total spending in the economy falls. Businesses see lower demand and reduce production. They lay off workers, incomes fall, the households trying to protect themselves by saving more find themselves with lower incomes, and their savings do not increase as expected. Everyone tried to save more and everyone ended up worse off. Keynes identified this in the 1930s. What is prudent for one actor is destructive when all actors do it simultaneously. The mechanism is real. It contributed to the depth of the Great Depression. What works for a household budget does not automatically work for an economy. The paradox does not say saving is bad. It says the relationship between individual prudence and collective outcomes is not simple, and that intuitions built at the household scale do not transfer reliably to larger systems. Imagine every person acting rationally to protect themselves and the protection failing for everyone because they all acted at once. What do you do when the individually correct action becomes harmful at the scale of everyone doing it? A single person standing up at a concert sees better. Everyone standing up means everyone sees equally badly. Individual rationality aggregated can produce collective catastrophe. What is virtuous in the particular can be harmful in the aggregate. Imagine every person acting rationally to protect themselves, and the protection failing for everyone because they all acted at once. What do you do when the individually correct action becomes harmful at the scale of everyone doing it? What do you do when the individually correct action becomes harmful at the scale of everyone doing it? The paradox of hedonism. Imagine that your only goal is to be happy. You pursue happiness directly, thinking about it constantly, measuring your experiences against it, arranging your life to maximize it. You find that the more deliberately you pursue happiness, the more it eludes you. The direct pursuit undermines itself. Mill described this from personal experience. He suffered a mental crisis in his 20s and concluded that those who are happiest have some other goal, pursuing it and finding happiness as a side effect. Viktor Frankl reached a similar conclusion from a very different direction. He wrote that happiness cannot be pursued directly. It must ensue. It is the unintended consequence of living for something other than itself. People who have clear purposes, who care about things beyond their own well-being, tend to report higher well-being than those who focus on well-being directly. The paradox is structural. Happiness requires being absorbed in something other than the question of whether you are happy. The moment you step back to assess your happiness, you are no longer absorbed. The self-consciousness required for the assessment destroys the state being assessed. This applies to pleasure, flow states, and many related experiences. The tennis player absorbed in the game is in flow. The player who stops to think about whether they are in flow is not. Imagine trying to sleep by trying very hard to sleep. What is the thing you most want that becomes less available the more directly you aim at it? Mill found this at a crisis point and wrote about it. The discovery made him less interested in his own happiness and more interested in the things that actually produced it. Frankl's formulation is the most precise. Happiness cannot be pursued, it must ensue. People absorbed in meaningful work or relationships tend to report higher well-being than those primarily absorbed in whether they are well. What is the thing you most want that becomes less available the more directly you aim at it? The paradox of choice. Imagine walking into a grocery store that offers 45 varieties of jam. An experiment in 2000 found that when a tasting table offered 6 jams, a significant portion of those who stopped bought. When the table offered 24 varieties, more people stopped but far fewer bought. More choice produced less purchase and less satisfaction. Schwartz found that more options produced less satisfaction for 2 reasons. More options raise the reference point. The chosen option must now beat 45 instead of 6. And more options produce more regret about the ones not chosen. The paradox is that freedom of choice, which seems unambiguously good, can produce worse outcomes than constrained choice. An abundance of options can paralyze rather than liberate. This runs against a deep assumption in economics that more options are always at least as good as fewer because you can always ignore the extra ones. But you cannot ignore them psychologically. Their presence changes the experience of choosing and the experience of having chosen. Imagine having every possible option available and finding that the availability makes every choice less satisfying. What would you choose more confidently if fewer options were available? Satisficers, who look for good enough rather than best possible, are largely immune to this paradox. They set a threshold and stop when they find something that meets it. Whether you can train yourself to satisfy in domains where you naturally maximize is an open question. Freedom past a threshold becomes its own burden. The ability to choose anything requires deciding what matters and why, which turns out to be harder than choosing from a smaller set someone else curated. Imagine having every possible option available and finding that the availability makes every choice less satisfying. What would you choose more confidently if fewer options were available? And does the confidence itself reveal something about what you actually want? The paradox of the surprise exam. Imagine a teacher announces on Friday that next week there will be a surprise exam. The exam will occur on a day students cannot predict in advance. A student reasons, the exam cannot be on Friday because by Thursday night no exam has occurred, so we would know it must be Friday, and it would not be a surprise. Eliminating Friday, the same logic eliminates Thursday. By Wednesday nights, with only Thursday and the eliminated Friday remaining, we would know it must be Thursday. The logic eliminates Wednesday, Tuesday and Monday the same way. The exam cannot be given on any day. The student concludes no surprise exam is possible. On Wednesday, the teacher gives the exam. The student is surprised. The student's reasoning seems valid at each step. The conclusion is demonstrably false. Identifying the precise error requires more philosophical machinery than it initially appears to. One approach says the issue is with what the teacher's announcement can coherently mean. Knowing that an exam will occur on an unknown day is different from being certain an exam will occur. The student's certainty that an exam is coming undermines the surprise condition. Another approach says the student's logic commits a fallacy by treating eliminated options as if they are genuinely impossible rather than merely predictable. What can a teacher honestly promise that a student cannot reason away? What the paradox reveals is the limit of perfect rationality applied to self-referential announcements. The surprise depends on the students not knowing, but the students can reason about what the teacher knows they know. That loop is what generates the instability, and it appears in game theory, wherever mutual knowledge becomes common knowledge. What can a teacher honestly promise that a student cannot reason away? On Wednesday, the teacher gives the exam, and the student is surprised. The logic was valid, the conclusion was false. What can a teacher honestly promise that a student cannot reason away? The paradox of the toxin puzzle. Imagine a billionaire offers you $1 million to intend tonight, to drink a mildly unpleasant but harmless toxin tomorrow afternoon. Not to drink it, just to genuinely intend to drink it. The money will be transferred at midnight, based solely on whether you have the genuine intention. By morning you can change your mind and not drink it. The money is already yours. Gregory Kafka posed this in 1983. The puzzle is that you cannot form the intention. You know that by tomorrow morning you will have no reason to drink the toxin. The money is already yours. Drinking it would be pointless discomfort. Knowing you will not drink it tomorrow, you cannot sincerely intend tonight to drink it. And without sincere intention, no $1 million. What makes this more than a thought experiment about money is what it reveals about intention. Intentions are connected to reasons. You can only genuinely intend to do something you believe you have reason to do. If you know by tomorrow you'll have no reason to drink the toxin, you cannot construct the intention tonight by sheer force of will. Whether self-binding commitments are possible, whether you can genuinely commit to future actions you expect to be irrational when they arrive, is a real question in decision theory, personal finance, addiction, and anything involving pre-commitment. Imagine trying to genuinely intend to do something you already know you will have no reason to do. What does it mean to make a promise to yourself that you know you will not keep? The toxin puzzle suggests you cannot manufacture the necessary mental state by deliberation alone. You cannot decide to be the kind of person who does something pointless. Real intentions require real reasons. The puzzle suggests intentions are not just another kind of belief. They are something different, requiring a live reason to remain genuine. What does it mean to make a promise to yourself that you know you will not keep? The paradox of the pre-commitment. Imagine Odysseus approaching the sirens. He knows the song will be irresistible. He has his sailors tie him to the mast and orders them not to release him, regardless of what he says. He pre-commits precisely because he cannot trust himself to choose correctly in the moment. Rational agency seems to require acting on your best judgment. Pre-commitment explicitly removes that ability. Odysseus succeeds precisely because he becomes unable to act on future preferences he knows will be distorted. Elster formalized rational pre-commitment. constitutional constraints, early withdrawal penalties, and addiction commitment devices all work because the current self restricts the future self it does not trust. In all these cases, a current self binds a future self it does not trust. The current self is considered more rational than the anticipated future self, which is a strange thing to claim given that you are both you. Whether the pre-committing self or the future self is the real you is not a neutral question. Imagine having to protect yourself from yourself by designing constraints your future self cannot escape. Which version of you is more trustworthy, the one making plans or the one who has to live them? Most of us assume the planning self is more rational, but the planning self has not yet heard the sirens. The practice of pre-commitment reveals that the self may not be a unified rational agent, but a collection of competing impulses that negotiate across time, sometimes by tying each other to masts. Which version of you is more trustworthy, the one making plans or the one who has to live them? The one who tied you to the mast or the one screaming to be untied? Which version of you is more trustworthy, the one making plans or the one who has to live them? The one who tied you to the mast or the one screaming to be untied? Which version of you is more trustworthy, the one making plans or the one who has to live them? The one who tied you to the mast or the one screaming to be untied? The friendship paradox. Imagine thinking about your social network. On average, your friends have more friends than you do. This feels like a personal failing, but it is a mathematical fact that applies to almost everyone, regardless of how popular you are. The reason is sampling bias. When you pick a random person in a network, you are equally likely to pick anyone. When you pick a random friend of a random person, you are more likely to pick someone with many connections, because popular people appear as a friend more often. The average friend of a random person has more connections than the average person, consistently, across almost any real social network. Scott Feld described this in 1991. The effect is real and measurable. Most people are below average in popularity compared to their friends, not because they are unpopular, but because the math of networks guarantees it for most nodes. The same effect applies to other quantities correlated with social connections. Your friends are more likely than you to have been to more parties, to have travelled more, to be more professionally connected. Social media amplifies the subjective experience of this, because the content you see is produced disproportionately by the most active people in your network. What makes this disturbing is not the math, but the human response to it. People compare themselves to their friends and feel insufficient, not knowing that the comparison is structurally rigged by how networks work. The feeling of being less than the people around you is, for most people, a mathematical consequence of having any social connections at all. Who are you comparing yourself to? And do you know that the comparison was never fair? In any network where connections are unequally distributed, the average neighbour is more connected than the average node. Your reference class for normal is systematically biased upward. The people you can see are not a representative sample. Whatever metric you use, the comparison was never fair. The paradox of the false accusation. Imagine you are falsely accused of something you did not do. You know you are innocent. You have access to a lawyer. You have the right to remain silent. Your lawyer advises silence. But consider what silence signals. In practice, juries and observers interpret silence as suspicious. Speaking freely might produce inconsistencies that damage your case. So the rational strategy for the innocent can look identical to the rational strategy for the guilty. This produces a paradox in the justice system. The procedural protections designed to protect the innocent, primarily the right not to incriminate yourself, produce behavioural patterns that make the innocent look guilty. The innocent act like the guilty because acting innocent carries strategic risks. Extend the logic. Innocent people are sometimes advised to plead guilty to lesser charges to avoid the risk of conviction on greater ones. The cost of fighting a false accusation can exceed the cost of accepting punishment for something you did not do. The rational response to a false accusation can be to confess. Innocent people plead guilty routinely, with the guidance of competent lawyers because the trial is too risky. Imagine a system designed to protect the innocent, in which the innocent are advised to act like the guilty. What happens to the concept of justice when the rational response to innocence is to behave as if guilty? The Innocence Project has exonerated hundreds of wrongly convicted people, a significant fraction of whom had confessed not under obvious coercion, but because fighting the charges was too expensive. The paradox is not a thought experiment. It describes a structural feature of adversarial legal systems with documented, predictable outcomes. Imagine a system designed to protect the innocent, in which the innocent are advised to act like the guilty. What happens to the concept of justice when the rational response to innocence is to behave as if guilty? The paradox of forgiveness. Imagine someone wrongs you seriously, they then apologize sincerely. You are supposed to forgive them, but forgiving them, truly releasing the grievance, seems to require acting as if the wrong did not matter. If you take the wrong seriously, you hold on to it. If you release it, you seem to be saying it was not as serious as you initially believed. Genuine forgiveness seems to require either minimizing the wrong or releasing a legitimate grievance for no reason. Neither seems fully coherent. Butler distinguished forgiving someone from condoning what they did. You can release the anger while still believing the action was wrong. Forgiveness is not a verdict on the action. It is a choice about how you relate to the person. Murphy argued that forgiveness, given too easily, is a form of self-disrespect. If you forgive without the wrongdoer acknowledging the harm, you signal that your dignity is not worth defending. Withholding forgiveness indefinitely also has costs. The anger tends to injure the person holding it as much as the person it is directed at. The thing that would make forgiveness coherent, genuine acknowledgement, and change by the wrongdoer is exactly what is often absent. What do you do with a wrong that cannot be undone by the person who committed it? Forgiveness is one of the things humans invented to navigate the asymmetry of harm. The harmed person cannot undo the harm. The person who caused it can acknowledge but not reverse it. Both work with the wreckage of something that happened and cannot unhappen. Forgiveness, as Butler understood it, is not about the other person. It is about what you do with what they left you holding. What do you do with a wrong that cannot be undone by the person who committed it? Forgiveness navigates that asymmetry. Whether it resolves it is a different question. What do you do with a wrong that cannot be undone by the person who committed it? And what do you do if the person who needs to answer that question is you? The paradox of courage. Imagine courage requires feeling fear. An action taken without fear is not courage, but indifference. And yet courage also requires acting despite the fear, not being controlled by it. So courage requires fear and requires overcoming fear simultaneously. Aristotle called courage a mean between cowardice and recklessness. The coward feels too much fear, the reckless person too little. The courageous person feels appropriate fear and acts anyway. But what counts as appropriate? A soldier who feels no fear before battle might be physiologically unusual rather than reckless. A person who feels overwhelming fear before a mildly risky situation might have an anxiety condition rather than cowardice. The line between appropriate and inappropriate fear is not fixed and cannot be read off behaviour alone. The deeper problem is whether courage is a virtue if it requires fear. Acting rightly when it is easy is not particularly admirable. Acting rightly when it is costly and difficult is. But the fear that makes an act costly also makes it less under rational control, which seems to reduce rather than increase the moral credit for it. Plato had Socrates argue in the Laches that courage is knowledge of what is truly fearful and what is not. On this view, the truly courageous person fears the right things and is not troubled by the rest. The feeling of fear becomes irrelevant. What matters is correct judgment. Most people's experience of courage does not match Plato's description. What would it mean to do the right thing in conditions that make doing the right thing feel genuinely dangerous? The traditional concept of courage was defined around visible, dramatic risk. The courage required to endure chronic pain or social exclusion was underweighted because it was not dramatic in the expected way. The paradox of courage is partly about which fears count. What would it mean to do the right thing in conditions that make doing the right thing feel genuinely dangerous? The twin paradox. Imagine two twins. One stays on Earth, the other travels near the speed of light and returns. The travelling twin is younger when they reunite. This seems paradoxical because from the travelling twin's perspective, it was Earth that moved. Both cannot be younger than the other. The resolution is that these situations are not symmetric. The travelling twin accelerates, decelerates, turns around, and accelerates again. The Earth twin does not. Acceleration distinguishes the two frames in a way that velocity alone does not. The asymmetry resolves the apparent paradox. Atomic clocks on GPS satellites must be corrected for time dilation. or the navigation system accumulates errors of kilometers per day. The correction is applied. Time dilation is not a theory. Time is not a universal backdrop. It flows at different rates in different conditions. The twins are not a thought experiment. They are physics. Imagine your sibling having lived measurably fewer seconds than you because of where they have been. What does it mean for time to be personal rather than shared? Muons produced by cosmic rays at the top of the atmosphere should decay before reaching the ground by classical calculation. Time dilation extends their subjective lifetimes enough that they arrive at sea level and are detected every second. Relativistic time dilation is not a theory. It is something you are standing in the consequences of right now. Imagine your sibling having lived measurably fewer seconds than you because of where they have been. What does it mean for time to be personal rather than shared? The situations are not symmetric. The travelling twin accelerates, decelerates, turns around. Acceleration distinguishes the frames. Time runs at different rates for different objects, measurably, right now. What does it mean for time to be personal rather than shared? What does it mean for time to be personal rather than shared? Time is not a universal backdrop. It flows at different rates in different conditions. Olbers Paradox. Imagine looking at the night sky. Between any two stars you can see another star, and between those, another. If the universe is infinite and filled with stars distributed roughly uniformly, every line of sight should eventually terminate on the surface of a star. The entire sky should be as bright as the surface of a star. It should be blindingly bright at all times. It is not. The night sky is dark. Olbers articulated this in 1823. Edgar Allan Poe proposed a correct solution in 1848. The universe has not existed forever, so light from distant enough stars has not had time to reach us. The modern resolution combines two factors. The universe is expanding, which redshifts distant light out of the visible spectrum. And the universe has a finite age, about 13.8 billion years, meaning only stars within a sphere of that radius have had time to send us light. The darkness of the night sky is direct evidence that the universe had a beginning. What disturbs people when they sit with this is the implication. The darkness outside your window is not emptiness. It is the edge of the observable universe. The distance light has travelled since the beginning of everything. Look anywhere in the dark sky, and you are looking at the boundary of what time has made visible. Beyond that boundary, in principle, space continues, just not in a way that has had time to reach you yet. What does it mean to be surrounded by a universe that extends beyond what can ever be seen? The cosmic microwave background is the light from 380,000 years after the Big Bang, redshifted into the microwave spectrum by universal expansion. What looks like darkness between the stars is full of this ancient light, too stretched to see without instruments. The emptiness is an artifact of your range. The darkness of the night sky is evidence that the universe began. What does it mean to be surrounded by a universe that extends beyond what can never be seen? The paradox of the fine-tuned universe. Imagine the fundamental constants of physics set slightly different. The gravitational constant a little stronger. Stars collapse too quickly for life to develop. The cosmological constant a little larger. The universe expands too fast for matter to clump into stars at all. The strong nuclear force weaker. Protons cannot fuse, and there are no elements heavier than hydrogen. The values that govern the universe appear to sit in a narrow range that permits complexity, chemistry, and ultimately life. Physicists call this fine-tuning. The values are not explained by any current theory. They happen to sit in a narrow range compatible with the existence of things that can notice them. 3 kinds of responses exist. Anthropic. We could only ask this question in a universe compatible with our existence, so there is no surprise that we find ourselves in one. Multiverse. There are many universes with all possible constants, and we are in one of the rare ones that works for the same reason. Design, someone set the values. What all 3 responses share is that they explain the fine-tuning by placing it in a larger context. Many observers, many universes, or an intentional setter. None explains why the constants have values at all, rather than no values. Imagine the universe being precisely calibrated to produce you without any explanation of who did the calibrating or why there are calibrations to make. What does it mean to exist in a system whose parameters seem adjusted for your existence? The cosmological constant is fine-tuned to within 1 part in 10 to the 120th compared to values quantum field theory predicts. Something cancels the predicted value almost perfectly. Whether that cancellation is a coincidence, anthropic selection, or evidence of physics we do not yet understand is called the cosmological constant problem. It does not have an answer. What does it mean to exist inside a system whose parameters seem adjusted for your existence? Maxwell's demon paradox. Imagine a tiny demon sitting at a door between two chambers of gas. The gas molecules move randomly at different speeds. The demon watches each molecule approach the door. Fast molecules going right get let through. Slow molecules going left get let through. All others are blocked. After a while, all the fast molecules are on one side and all the slow molecules are on the other. One side is hot. One side is cold. The demon has created a temperature difference from an initially uniform gas, apparently without doing any work. Maxwell proposed this demon in 1867. If it exists, you could run a heat engine on the temperature difference it creates, extracting work from nothing. This violates the second law of thermodynamics. Szilard pointed out in 1929 that measuring each molecule requires information, and information has a thermodynamic cost. Landauer showed in 1961 that erasing information has a minimum energy cost. The demon's memory must be erased to complete the cycle, and that erasure produces exactly enough entropy to satisfy the second law. The demon is defeated not by its measurements but by its forgetting. Wiping a bit of memory costs energy. The second law is saved by the thermodynamics of information itself. Imagine information having weight. Not metaphorically, thermodynamically. What else might have a physical cost that we are treating as if it is free? Some physicists argue information is more fundamental than matter or energy, that the universe is, at its deepest level, information being processed. Whether that is insight or metaphor is still being argued. What the demon cannot do is measure without cost, and the cost is paid in exactly the right amount to keep the universe consistent. Imagine information having weight, not metaphorically, thermodynamically. What else might have a physical cost we are treating as if it is free? The second law is saved by the thermodynamics of information itself. Imagine information having weight, not metaphorically, thermodynamically. The Mpemba Paradox. Imagine two identical containers of water. One is at room temperature, around 20 degrees. The other is at near boiling, around 90 degrees. You place both in a freezer at the same time. Under some conditions, the hot water freezes first. Aristotle noticed this. Franciscan Bacon wrote about it. In 1963, a Tanzanian student named Erasto Mpemba noticed it while making ice cream and brought it to his physics teacher, who dismissed him, then eventually tested it. The effect was confirmed. It is named after him. Why it happens is still genuinely debated. Proposed mechanisms include evaporation, reducing the mass of the hot water, dissolved gases that escape when water is heated, affecting freezing, convection currents established in hot water that persist and accelerate cooling, and hydrogen bond structures that differ between hot and cold water. No mechanism is universally accepted. What makes this disturbing is not the effect itself, but what it demonstrates. A simple observation about water and temperature, something humans have had the means to test for thousands of years, was dismissed as obviously impossible until someone tested it carefully. The assumption that hot water cannot freeze faster than cold water was so strong that the observation was ignored. How many other things that seem obviously impossible have been dismissed without testing? What do you believe is too counterintuitive to be worth checking? The effect has not been definitively explained. Studies have found it, failed to replicate it, and found it again. The literature is inconsistent. Some real effects resist the conditions required to study them cleanly. A phenomenon that exists but is not robust enough to isolate cleanly is its own kind of disturbing. How many other things that seem obviously impossible have been dismissed without testing? Very simple phenomena about very common substances can resist clear explanation for a long time. What do you believe is too counterintuitive to be worth checking? The Coastline Paradox. Imagine measuring the coastline of Great Britain. You use a measuring stick 100 kilometers long. You step around the coast counting lengths. You get a number. Now use a stick 50 kilometers long. Smaller increments follow the curves more closely. You get a larger number. Use a 10-kilometer stick and you follow inlets that the longer stick skipped. Larger still. Richardson documented this in the 1950s. the measured length depends entirely on the scale of measurement. As the scale approaches zero, the measured length approaches infinity. Real coastlines are fractally rough at every scale. Mandelbrot formalized this with fractal geometry in 1967. Coastlines, clouds, trees, and blood vessel networks all have this property. Nature is full of objects that have no single well-defined size. This matters beyond geography. Risk models assume smooth curves and well-defined boundaries. When the underlying reality is fractal, smooth models produce systematically wrong predictions. Financial markets, earthquake magnitudes, and internet traffic all have fractal properties that standard statistical models underestimate. Imagine asking what size something is, and discovering that size is not a property the thing has. What else might be depending on the scale you chose to look at it in ways you have not noticed? Mandelbrot revealed that natural objects, financial price series, mountain ranges, lung tissue, all show fractal properties across multiple scales. Euclidean geometry fails to describe them accurately. Models built on smooth assumptions applied to fractal systems can be wrong by orders of magnitude, as risk managers in financial markets discovered. Imagine asking what size something is and discovering that size is not a property the thing has. What else might be depending on the scale you chose to look at in ways you have not noticed? What else might be depending on the scale you chose to look at it in ways you have not noticed? Size turns out to be something you choose. The potato paradox. Imagine 100 kilograms of potatoes. They are 99% water by weight. You leave them out overnight and they dry to 98% water. How much do they weigh now? 50 kilograms, half their original weight, from a 1% change in water content. The arithmetic is correct. Originally 99 kilograms were water and 1 kilogram was solid. After drying, the solid content has not changed, still 1 kilogram, but now the solid is 2% of the total rather than 1%. So 1 kilogram is 2%, meaning the total is 50 kilograms. 99 kilograms of water became 49 kilograms. The result feels wrong because the stated change is small, 1%, and the result is large, 50% weight loss. But the 1% refers to the fraction of water, not the amount removed. A tiny change in the percentage of water content implies a large change in the total weight when the water fraction is already very high. This class of error appears in real contexts. Medical statistics expressing survival rates as relative risk reductions can make small absolute improvements look large. Economic statistics expressed as percentages of percentages compound in ways that contradict intuition. Pharmaceutical advertising routinely uses relative risk reduction rather than absolute risk reduction because the numbers look more impressive. Imagine a tiny percentage change producing results that seem impossible until the arithmetic is shown. What statistics are you accepting that might have the same shape as the potatoes? Percentage language can obscure absolute changes. A drug reducing heart attack risk from 2% to 1% has reduced relative risk by 50%, but absolute risk by 1 percentage point. Both statements describe the same result. One sounds like a breakthrough. Most people read only the dramatic one. What statistics are you accepting that might have the same shape as the potatoes? The paradox of the arrow of time. Imagine filming a cup falling off a table and shattering on the floor. Now play the film backward. You can immediately tell which direction is forward. A shattered cup spontaneously reassembling itself and leaping onto a table is obviously wrong. Time has a direction, but the fundamental laws of physics do not. The equations of classical mechanics, electromagnetism, and quantum mechanics are all time-symmetric. They work equally well forward and backward. Nothing in the laws themselves prevents a shattered cup from reassembling. It is not forbidden. It is just extraordinarily improbable. Ludwig Boltzmann explained this through statistical mechanics. There are vastly more disordered arrangements of atoms than ordered ones. A cup spontaneously assembling from shards would require all its atoms to coordinate in a highly specific way from among an astronomically larger number of disordered arrangements. The probability is not zero. It is just so small it has essentially never happened in the history of the observable universe. Why entropy increases in the forward direction rather than the backward direction turns out to require explaining the initial conditions of the universe. The universe started in an extremely low entropy state. Boltzmann could not explain why, and the explanation of that initial state is still not complete. The arrow of time, the direction in which broken cups do not reassemble, turns out to be one of the deepest unsolved problems in physics. Imagine time having a direction only because of how unlikely the alternatives are. What does it mean for the past to be past if the laws of physics do not require it? Penrose estimated the probability of the universe's initial states occurring by chance as 1 in 10 to the power of 10 to the power of 123. Whether the initial state was inevitable, chosen, or random is the deepest question the arrow of time points towards. The question may be the hardest in physics, the Zeno-arrow paradox. Imagine the arrow again, but consider not its flight but the moment of its stillness. At every instant of its flight, the arrow occupies a space exactly equal to its own size, and nothing else. At each instant it is stationary. Time is composed of instants. At each instant the arrow is at rest. When does the arrow move? This is the same arrow paradox, but approached from the direction of time rather than space. Motion requires change of position over time. At a single instant of time there is no change because there is no time interval over which change can occur. If you break time into instants of zero duration, motion vanishes. If you try to build motion back up from these zero duration instants, you cannot, because adding any number of zeros gives you zero. Calculus provides instantaneous velocity as a limit, the ratio of position change to time change as the time interval approaches zero. This gives a well-defined number even at a single instant. But instantaneous velocity is a property of a trajectory, a function of positions across a range of times, not a property of the arrow at a single moment. Whether the arrow at a single instant is moving or still, whether instantaneous velocity is a real property or a mathematical convenience applied to a trajectory, is a question physics does not need to answer to make accurate predictions. The answer matters only philosophically. Whether philosophy and physics need to give the same answer is itself a contested question. What is the arrow doing right now, at this specific instant, that makes now different from stopped? The question is whether motion is fundamental or derived. On one view, position is fundamental, and motion is calculated from positions at different times. On another, motion is fundamental, and positions are snapshots of something dynamic. Whitehead argued reality is fundamentally events and processes. Motion is not something objects do. Whether it resolves Zeno depends on whether you find it more coherent than what it replaces. The Grelling-Nelson Paradox. Imagine dividing all adjectives into two categories. An adjective is autological if it describes itself. Short is a short word. Polysyllabic is polysyllabic. An adjective is heterological if it does not describe itself. Long is not a long word. French is not a French word. Monosyllabic is not monosyllabic. Adjectives that do not describe themselves are heterological. Now ask, is heterological heterological? If it is, it describes itself, which means it is a word that does not describe itself, which means it is not heterological. If it is not, it does not describe itself, which means it fails to be heterological, which means it is heterological. Either answer contradicts itself. Kurt Grelling and Leonard Nelson identified this in 1908. It is a version of Russell's paradox transposed into natural language. The same self-referential structure that breaks set theory when you ask about the set of all sets that do not contain themselves breaks here when you ask about the adjective that describes adjectives that do not describe themselves. The paradox shows that the distinction between autological and heterological, which seem perfectly clear and coherent, contains a hidden self-reference that makes at least one case undecidable. Imagine every apparently clean classification containing a case at its edge, where applying the classification to itself produces a contradiction. What other categories seem perfectly clear until you ask whether the category falls into itself? The Grelling-Nelson paradox does not become inert once you understand it. Is heterological heterological still demands an answer? No answer is available. Understanding the structure does not make the demand go away. What other apparently clean categories collapse the moment you ask whether the category falls into itself? And is heterological heterological? Grelling died in Auschwitz in 1942. The paradox survived him, appearing now in logic courses stripped of the biographical context that might make it heavier. Richard's Paradox. Imagine all the real numbers that can be defined in English in a finite number of words. There are infinitely many such numbers. but the set of finite English phrases is countable, meaning you can list them: the first phrase, the second, the third, and so on. Enumerate all the definable real numbers in this order. Now construct a new real number as follows. The first decimal digit is different from the first decimal digit of the first number. The second decimal digit is different from the second digit of the second number. And so on. This diagonal construction produces a number that differs from every number on the list in at least one decimal place. But this new number has just been defined in English in a finite number of words. The number produced by taking the diagonal of the enumerated list of definable real numbers. So it is a definable real number and should be on the list. But it was constructed to differ from every number on the list. Jules Richard identified this in 1905. The paradox involves a set that seems well defined but turns out to be self-referential in a problematic way. The collection of all English definable reals cannot be coherently defined in English without producing a number that both is and is not in the collection. The resolution follows the same lines as Russell's and Berry's paradoxes. Self-reference at certain levels generates contradictions, and formalizing what counts as a definition requires careful attention to what level of the hierarchy you are operating at. What disappears the moment the description is included in the set of things it describes. Richard's paradox anticipated Gödel by 25 years. Both involve constructing a statement a system cannot consistently contain. The diagonal construction, defining something by how it differs from every member of a list, is the same technique in both. Cantor used it for set sizes, Richard for descriptions, Gödel for proofs. It is one of the most unsettling tools in the foundations of mathematics. The card paradox. Imagine a card with text on each side. One side says the sentence on the other side of this card is true. The other side says the sentence on the other side of this card is false. Call side 1A and side 2B. If A is true, then B is true, because A says B is true. But if B is true, then A is false, because B says A is false. Contradiction. If A is false, then B is false, because A says B is true, and A is false, so B is the opposite of true. But if B is false, then A is true, because B says A is false and B is false, so A is the opposite of false. Contradiction again. This is the liar paradox distributed across two separate statements rather than one, creating mutual reference. Neither statement refers to itself, but together they create a loop that generates the same contradiction. Two apparently innocent statements, each pointing to the other, produce the same instability as one statement pointing to itself. What the card paradox demonstrates is that the problem is not self-reference specifically, but circular reference, a closed loop of statements that ultimately predicate truth or falsity of each other, without any grounding in non-referential facts, can produce paradox even when each individual link in the loop is well formed. Imagine two people who each claim the other is lying about whether the other is lying. What is the minimum number of statements needed to create a paradox of this kind? And are any of your current beliefs arranged in a loop like this? The cards have no grounding outside each other. Each side is defined only by what the other says about it. Without an external anchor, the loop has no determinate truth value. The cards look like they are saying something. They are pointing at each other in the dark. Imagine two people who each claim the other is lying about whether the other is lying. Now imagine it being impossible to resolve from outside. What is the minimum number of statements needed to create a paradox of this kind? The exception paradox. Imagine the rule. There are no exceptions to this rule. If it is true, it holds universally. But if one case fails, it has an exception. If the rule about no exceptions has an exception, the rule is false. If it is false, there are exceptions to the rule about exceptions. More interesting is the phrase, the exception that proves the rule. It comes from a Latin legal principle. The exception proves the rule in cases not accepted. The existence of a specific exception demonstrates that a general rule exists. No exceptions without a rule. No rule without the possibility of exceptions. The two define each other while seeming to exclude each other. Applied more broadly, any sufficiently general principle generates cases at its edges where the principle does not cleanly apply. The existence of hard cases does not show the principle is wrong. It shows the principle is real enough to have edges. A principle with no hard cases is probably too vague to mean anything. The exception sits at the boundary of every rule, waiting to be either the thing that breaks it or the thing that proves it exists. Imagine every rule you follow having exactly one case where applying it produces the wrong result. What do you do with a principle that is right in general and wrong in a specific case that you can clearly see? Equity in law exists precisely to handle cases where applying the rule produces an unjust outcome. The exception that proves the rule is not just a saying, it is a design principle embedded in how law handles the boundary between the general and the particular. What do you do with a principle that is right in general and wrong in a specific case you can clearly see? What do you do with a principle that is right in general and wrong in a specific case you can clearly see? Any general principle generates cases at its edges where it does not cleanly apply. Hard cases show the principle is real. What do you do with a principle that is right in general and wrong in a specific case you can clearly see? The paradox of the interesting number. Imagine dividing all positive integers into two categories, interesting and uninteresting. 1 is interesting, it is the first positive integer. 2 is interesting, first even number. 3 is interesting, first odd prime. 4 is interesting, first perfect square. And so on. Suppose the uninteresting numbers form a non-empty set. The set of uninteresting numbers has a smallest element. That smallest uninteresting number is interesting because it has the property of being the smallest uninteresting number. Contradiction. Therefore, all numbers are interesting. This is usually presented as a joke, but it has a real version. The concept of interest is defined relative to a context, a background of other numbers, a purpose, a perspective. No number is interesting or uninteresting in itself. Interest is relational. And the paradox exploits the relational nature of the concept by making the very collection of uninteresting numbers supply the interest of its own smallest element. The joke version gestures at something real about self-defeating classifications. Any classification that treats belonging to the category of uncategorized things as a categorization will generate paradox. This is a softer version of Russell's paradox, dressed in lighter clothes. What the paradox actually reveals is that concepts like interesting are context-dependent in ways that make them behave strangely when you try to apply them universally or to themselves. Imagine every number you are about to call boring immediately becoming interesting because you noticed it is the most boring one you have come across today. What makes something interesting enough to notice? Interest is not a property of numbers. It is a relationship between numbers and minds. A number is boring relative to a context. Every number is the answer to some question. The conclusion that all numbers are interesting, while seeming absurd, follows from what boring actually means. What makes something interesting enough to notice? The paradox of the intentionally blank page. Imagine a page that says, "This page intentionally left blank." The page is not blank. It contains text. The text says the page is blank. The text makes the statement it contains false by the act of containing it. This is a small and familiar paradox, but it sits in the same family as the liar. A statement about the state of the surface it is written on cannot be true and be written on that surface simultaneously. The blank page that announces its own blankness has already failed. Publishers use this convention to explain that a blank-looking page is not a printing error. The intention is practical and the reader understands it. No one is actually confused. But the logical content of the statement, "This page is blank," is false the moment it is printed. What makes this more interesting than a publishing quirk is the class of statements it exemplifies. Statements whose content is undermined by the conditions required to communicate them. A whispered announcement that you are being quiet undermines itself. A formal statement that all communication is impossible is itself communication. An argument that no conclusions can be drawn draws a conclusion. Self-undermining statements appear at the edges of many serious claims in epistemology, philosophy of language, and the foundations of knowledge. They are not mere wordplay. They mark places where the relationship between a claim and its conditions of assertion breaks down. Imagine a belief that becomes false the moment you commit to it. What are you trying to say that requires conditions you cannot have while saying it? Philosophers call these performative contradictions. To perform the act is to contradict the content. They are not wordplay. They mark structural limits on what can be coherently said. The blank page is one of the gentler examples. The deeper ones appear at the foundations of epistemology, where the conditions required to make a claim undermine the claim being made. the paradox of the omniscient God. Imagine a being that knows everything, including all future events. If it knows the future completely, the future is fixed. Every event that will happen is already determined, in the sense that the knowledge of it cannot be wrong. But if the future is fixed, nothing can be different from what will happen. Free will, the ability to have done otherwise, seems to require that the future could have been different. If the future is already known, it could not have been different. Free will appears impossible under omniscience. This is the foreknowledge paradox, and it has troubled theologians since Augustine. The responses fall into a few types. Compatibilism. God knowing you will make a choice does not cause you to make it. Your choice is still free, even if it was foreknown. Open theism. God chooses not to know the future, or the future involving free choices is genuinely not knowable, even to God. Middle knowledge. God knows what every person would freely choose, in every possible circumstance, which is a kind of knowledge that does not determine outcomes. None of these responses satisfies everyone. Compatibilism requires a concept of freedom that does not involve the ability to have done otherwise. Open theism limits divine knowledge. Middle knowledge raises questions about the logical status of counterfactual free choices. Imagine a being watching a film of your life and knowing how it ends while you are still in it, claiming you are freely choosing. What does freedom mean if what you will choose has already been witnessed? The foreknowledge paradox has no consensus resolution after 1500 years of serious theological and philosophical work. It remains open at the intersection of metaphysics, philosophy of action, and the philosophy of religion. Imagine a being watching a film of your life and knowing how it ends while you are still in it, claiming you are freely choosing. What does freedom mean if what you will choose has already been witnessed? The paradox of moral luck. Imagine two drunk drivers. Both drive equally recklessly on the same night under the same conditions. One arrives home safely, the other hits and kills a pedestrian who stepped onto the road. The first is guilty of reckless driving, the second is guilty of vehicular homicide. Their moral and legal situations are radically different, though the difference between them was entirely determined by factors outside their control. Thomas Nagel and Bernard Williams both wrote about this in 1979 and both found it deeply troubling. We hold people responsible for outcomes, but outcomes are partly determined by luck. The drunk driver who kills someone is not just unlucky, they are also more guilty in how we actually treat them. And yet the only difference between the two drivers is a pedestrian's path. Nagel identified several kinds of moral luck. Resultant luck, the luck of how things turn out. Circumstantial luck, the luck of what situations you face. Constitutive luck, the luck of who you are. All three affect moral judgment, even though none is within the agent's control. The paradox is that we believe people should only be judged for what is within their control, and we also believe outcomes matter morally. And these two beliefs cannot both be true when outcomes depend on luck. Imagine being a different moral person than you are purely because of where you happen to be standing when something happened. How much of your character is yours, and how much is the luck of which situations found you? Nagel concluded the inconsistency is permanent. No coherent system of moral judgment can be fully purged of luck without becoming unrecognizable. Our moral concepts are inconsistent in a way that cannot be fixed without abandoning things we cannot abandon. Imagine being a different moral person than you are purely because of where you happen to be standing when something happened. How much of your character is yours, and how much is the luck of which situations found you? The paradox of self-deception. Imagine believing something you know to be false. Self-deception seems to require that you simultaneously believe and disbelieve the same proposition. You cannot deceive yourself without knowing the truth you are hiding from yourself. And if you know the truth, in what sense are you deceived? Humans clearly engage in self-deception. People maintain beliefs about their own abilities that contradict available evidence, avoid information that would update them, and often, at some level, know what they are doing. Jean-Paul Sartre called this bad faith, a kind of flight from freedom. The bad faith agent refuses to acknowledge something they are aware of because the acknowledgement would require them to change or to take responsibility. The knowing and the not knowing coexist at different levels of attention. Modern psychology describes something similar. People maintain what researchers call split beliefs, or motivated reasoning, where conscious belief and implicit belief point in different directions. The explicit self-report says one thing, behavioural evidence says another. neither is quite the whole truth. What makes the paradox genuinely unsettling is that the mechanism that enables self-deception is the same mechanism that protects psychological functioning. Some things are too painful or disorienting to hold fully in view all the time. The line between self-deception and adaptive coping is not always clear, even from the inside. What do you know at some level that you have arranged your life not to have to look at directly? And how confident are you that the arrangement is working? The question is not whether you are self-deceived, but in where and about what. The honest answer requires the same capacity for clear-eyed self-examination that self-deception is specifically organized to prevent. What do you know at some level that you have arranged your life not to have to look at directly? And how confident are you that the arrangement is working? The paradox of the eternal return. Imagine that everything that has ever happened will happen again, in exact sequence, infinitely many times. Not as a metaphor, as a fact about time and matter and the eventual repetition of all configurations in a universe of finite possible states and infinite time. This specific night, this exact feeling, this particular moment of being almost asleep while something speaks to you out of the dark. Nietzsche did not prove this cosmologically. He used it as a weight. A demon, he said, comes to you in your loneliest moment and tells you that you will live your life again. Every pain and every joy, not once, but infinitely, many times. Would you collapse? Or would you want to live it exactly as it has been? The question is not about belief in eternal return. It is about the relationship you have to your own life. A life you would want repeated exactly is a life you are living with full acceptance. A life you would reject as a repeating pattern is a life you have not yet made your own. Whether eternal return is cosmologically possible is a separate question from whether the thought experiment does its job. And the job it does is to make the weight of your choices absolute, not the weight of future consequences, which most ethics attaches to. The weight of what you are already doing and who you are already being now, in this moment, forever. 100 paradoxes have led here, each one a door that opens into questions that cannot be closed from inside the room you are standing in. And this is the last one. Not a logical trap, but a mirror, asking whether what you see in it is something you would choose. What would you do differently tomorrow if you believed tomorrow was also forever? Reality is stranger than it appears. Language reaches limits. Logic has edges. Consciousness cannot see itself. And time keeps moving in the one direction it is allowed to go, carrying everything with it, including this thought, which is now already in the past.